Okay, good morning everyone. I think we're about ready to start. Okay, thank you very much for coming. It's great to welcome you all here today. I'm absolutely thrilled with the attendance and our lineup today. So some very brief housekeeping before we start formally. We're not expecting any fire alarms today, you'll be happy to know, but if you do hear the alarm, would you please exit via the left and the right of the room and meet at the main car park to the side of the building there. We can access then the agenda for the day. If you look at your name badge, there's a QR code, so just scan that and you will get the programme for the day. We'll try to keep to time, but it will be tough today. We've got a jam-packed programme. And if you could try and be back in your seats promptly, it would really help the day to flow. We'll have photography later on, so if you don't want to be part of that, please let one of our sustainability team know. And we're absolutely thrilled to have our guests with us today, so this is great. I'd like to hand over to Michael Alcorn, Associate Pro-Vice Chancellor for Sustainability and Strategic Projects at Queen's University to start. Please welcome Michael.
Thank you very much, Nathan, and a warm welcome, everyone. Thank you for joining us today. It's my great pleasure to welcome you all here to Queen's University and to this year's Sustainable Construction Conference. We're delighted to welcome representatives from across Northern Ireland, from Scotland, England, and the Republic of Ireland. There must be somebody here with Welsh ancestry we can fill that little gap. But amongst you are government and civic leaders, policymakers, business representatives, NGOs, industry professionals, as well as staff and students from Queen's. So you're all extremely welcome here today. The breadth of participation in this event, I guess, reflects a shared commitment to tackling one of the most urgent challenges of our time, the climate and ecological emergency. One need only glance at the news headlines day and daily to get a sense of the urgency of this issue: record-breaking temperatures, devastating wildfires, rising sea levels, and the alarming loss of biodiversity. The science has been very clear for decades, but more than ever, we need to be taking decisive action to mitigate these effects. So at Queen's, we've taken a very proactive role around sustainability. First of all, acknowledging the environmental impact of our construction activities, and secondly, by seeking ways to minimise that impact. In October 2023, we launched our Net Zero Plan, a commitment to achieving net zero across all of our emissions by 2040. Since launching that plan, we've taken some decisive steps, including publishing a net zero design guide, which establishes a new standard for all capital projects to transition towards net zero. We've also embedded energy performance standards such as Passive House in our estate, with our first Passive House certified building, a 450-bedroom student accommodation project set for completion in 2026. And in other ways, through the installation of over 250 kilowatts of solar PV, generating clean and renewable energy on site. We've also been mandating a whole-life carbon assessment for all capital projects exceeding £1 million, ensuring that carbon reduction is prioritised from the earliest stages of the design. Other organisations who are here today are also on that journey, and just by way of example, we would mention Belfast City Council's Local Energy Area Plan, LEAP, building a strategic case for local energy system decarbonisation in Belfast. Or Northern Ireland Housing Executive's approach to energy efficiency, adopting best practice standards within their new and existing housing stock. And Best's retrofit of their Accelerator Lab as part of their National Refit Centre in Glasgow, acting as a living demonstrator project, showcasing non-domestic retrofit practice. So the momentum is clear, but so too is the scale of the challenge that remains. And that's why today's conference is an important point in providing an opportunity to reflect on progress, to recognise the challenges ahead, and to strengthen our commitment to meaningful change. Last year's inaugural conference was Sustainable Construction Conference on carbon reduction, primarily in new buildings. Given feedback from that, It seemed very clear that the reuse of existing buildings must be a focus for discussion on carbon reduction, and hence the title for this year's conference, Refurb Renaissance, prioritising the reuse of buildings in the transition to net zero future. The term Renaissance, meaning revival, speaks of the need to reimagine our approach to the built environment, prioritising reuse over new build to unlock significant carbon savings. Well, this is where we all have a role to play. Those in the room today have a unique opportunity to influence decision-making and to drive real change, both in Northern Ireland and beyond. And I encourage you, each of you, to actively engage in today's discussions, share your perspectives, ask questions, and explore solutions that will define the next chapter of our built environment. That's enough from me. I'm really the warm-up act for our main facilitator today, Dr. Siobhan Cox. Siobhan is a senior lecturer in civil and environmental engineering in the School of Natural and Built Environment here at Queen's. Siobhan researches the environmental impacts of construction and brings particular expertise in the life cycle assessment of novel concrete products. She has led several major research projects looking at the whole life cycle environmental impacts of low-carbon geopolymer concrete products, and is a supervisor of a KTP with Northstone Materials to utilise waste materials in the production of low-carbon concrete roof tiles. Before entering academia, Siobhan worked in an engineering consultancy, attaining chartered engineer status with the Institute of Civil Engineers. She brings this experience to her work with construction companies to reduce embodied carbon in construction, undertaking whole life carbon calculations and identifying embodied carbon reductions in both buildings and in infrastructure. So will you please join me in welcoming Siobhan, the facilitator for today. Thank you very much.
So thank you very much, Michael, for that introduction. I'm really delighted to be here today. I've been reading through the programme and I've had a sneak peek at some of the presentations, and I can assure you that it's going to be a really fascinating day. So new buildings are often portrayed as a symbol of progress and a thriving economy. But in an increasingly resource-constrained world, should we be so quick to demolish and rebuild? Globally, construction uses 50% of all resources, produces 30% of waste, and negatively impacts 30% of endangered species. Operating and constructing the built environment contributes nearly 40% of global greenhouse gas emissions, which means that the decisions we make now, whether to demolish and rebuild or to retrofit and reuse, will deeply affect future generations' progress on climate change. With sustainability and ESG considerations increasingly driving the agenda of developers, investors, financiers, pension funds, and many occupiers, the question of whether to refurbish existing stock or to demolish and rebuild entirely is not an easy one. Letty's guidance highlights that up to 70% of a modern energy-efficient building's whole life carbon can be locked into its structure and materials before it even opens. The UK Green Building Council's research reinforces this by advocating for a retrofit-first approach, stressing that refurbishment, where possible, is almost always the lower carbon option when compared to demolition and new construction. Across the industry, we're beginning to witness a shift in the realisation that whole life carbon accounting is critical to our net zero strategy. Today's conference will explore the opportunities and challenges of this shift, showcasing best practice, policy insights and innovative strategies that can help us to decarbonise the built environment while making the most of the buildings we already have. However, carbon and resource use are not our only considerations. A truly sustainable approach must be holistic, encompassing not only carbon reduction, but also enhancing health and well-being, increasing biodiversity, integrating climate resilience, and providing social value. Today's event will explore all of these critical aspects, examining how they intersect and contribute to a more sustainable built environment. So it's my pleasure to introduce our first speaker of today, who will highlight key initiatives that in Belfast aimed at advancing the reuse of existing buildings on a citywide scale. Brenda Roddy is a highly experienced climate professional who recently returned to Northern Ireland after working with Scottish local authorities on climate change. She currently leads the carbon retrofit at Belfast City Council and coordinates the Belfast Retrofit Hub. We are grateful to Brenda for joining us this morning to provide valuable insights into the ongoing work of the Belfast Retrofit Hub and to discuss the sustainability landscape within Northern Ireland. Please join me in giving Brenda a warm welcome.
So I'm probably the shortest person that's going to be presenting today, so hopefully you can see me and hear me okay. And Nathan has promised to give me some kind of warning when I'm getting towards the end, okay? So the bit that always gets me is the clicky button bit. There we go. So I was trying to work out, if I've got 10 minutes, what you might actually want to find out. So we're going to be looking at just who we are, what our remit is, what we do, and what we're working on. So I'm going to take you through some of that, and at the end of it, I'll give you contact details for getting in touch, okay? So just looking at who we are is, as you just said, I work for the council, and although we don't have housing stock, we've got considerable public sector stock, and we also represent the citizens of Belfast. So we have a real interest in making retrofit happen. The hub itself, we set that up in September 2022, and that's because we'd carried out a carbon analysis of Belfast and realised that the built environment was such a major factor in all of this. So we convened the retrofit hub. We try to facilitate that, get everybody in the room. And my role is to nag, cajole, support, and try and get everybody to work together. So we're a group of 70 organisations, and that's about 150 members. Membership's really wide-ranging. It spans, we've got the housing providers, the government departments, you've got the skills providers, you've got material supply chain, construction, specialists, contractors as well. We've also got the utility providers, the banks, everybody. And the bear is for the organisations where I couldn't find an icon for them. So if you don't identify with that, you're a bear, and who doesn't love a bear? So the point is that we're all working together. I suppose the most important thing from this is just to show the amount of collaboration. What we found is all the different sectors and organisations, they're all working on really interesting things. And if we can pull what we know and what we found out, we can move ahead. So this tells you, this is what pushed us towards focusing on the built environment, because the carbon footprint for Belfast showed us that domestic was coming in about 40%, and then commercial and public buildings were coming in about a quarter of the emissions in Belfast. And in terms of homes, we're looking at about 156,000. And it's not just the council that prioritises this, it was our members were telling us as well that homes were their priority for focusing on. And when we look at them, we say, well, why are we looking at them? And one of the things, I'll look at our local area energy plan later on, but the data for that told us that about 63% of the homes in Belfast, their EPC rating is D or below. So that kind of gives us the remit to focus on it. It's worth pointing out as well that although we look at domestic, we do look at public and commercial, and unlike other retrofit hubs in the UK, they tend to just focus on domestic, and within that, they focus just on social housing. We do the whole shebang. So, but that's why we're looking at it, because of the EPC ratings, and we take a fabric-first approach. But we do have to take into account that about 2/3 of the homes in Belfast use gas. And I was quite shocked to come back from Scotland saying 29% of homes in Belfast use oil. That's mad. Over in GB, it's between 3% and 7%. So that tells you some of the things we're focusing on. I mentioned that we also take in commercial and public, and you might have seen this article last year when CBRE NI came out, and they said, look, by 2030 you could find that if the minimum energy efficiency standards legislation comes in, similar to GB, we could find that up to 3/4 of office stock in the centre of Belfast is unlettable. Now that's of interest clearly for commercial reasons, but a lot of that office stock is owned by the public sector as well. The council owns a good chunk of that, so we all have a vested interest in making sure it's fit for purpose. And that same legislation, we know it could impact on the private rental sector as well. It's a really tricky sector to retrofit, but we know that's come through the pipeline as well. And one of the things that we did in the last year was we were speaking to a lot of people who their role is to be facilities managers or to manage energy. And some of them were saying, look, we're new to this, it might be a new remit. They were saying, we don't know what everybody else is doing. Can we get some of the big boys together? So what we did is we ran an event, and Queen's came in. One of their finance people talked us through. They have this Invest to Save programme, where they basically have a pot, a revolving fund, where money is used to pay for low carbon efforts and the savings put back in. It's really successful. We find that really useful. The Belfast Trust talked us through how they set up and ran their power purchase agreement. The council at that event talked about the low carbon district heating scheme that we're currently exploring for the city centre. And we also talked people through the energy efficiency audits that we're carrying out on some of our estates, some of our biggest buildings. And so Rick Tracy talked us through that. And that's what the hub is all about. It's about sharing information so that we can just learn from each other. Looking back, digging into homes a wee bit, one of the things that we talked about earlier on, Siobhan and Michael referred to, is we know that a lot of the homes that are going to be here in 2050, about 80% of them are already here. So there are hardly any homes in Belfast, if any, that won't need retrofit. And we know that this Right Move report that came out in 2023, they said their analysis shows that homes where you can move them from an EPC rating of F to C can typically have an average premium increase of up to 15%. Now, one of the questions we're asking at the hub is, okay, well, that sounds lovely. Is that happening in Northern Ireland? Do we have evidence of that? Do we find that investment in retrofit is actually getting transferred back into the value of the property? So that's the kind of thing we'll dig into and try and see, well, are there any barriers there? Is there anything that we can do? So looking into all those great ambitions, what are our main priorities? We've got 5 aims, and the first one is to just build that community of organisations and people who want to be part of this. The second thing is we need that evidence, we need the data to show what works, how it works, and what impact it has as well. And then the other retrofit hubs were set up when funding was made available. We don't have those same large-scale funding pots, so we're taking the funding-ready approach. The idea is just develop our projects and be ready for when that funding comes online, and don't just wait on the big government programmes, because they are not a panacea. We've seen that in GB and Republic of Ireland. The other thing is the hub is all about catalysing, promoting collaborations. We're trying to get all of our members to work together. And the last thing is we've realised, as well as building in consideration of embodied carbon, we also have to build in resilience. One of our housing providers said, look, there's no point in us having this lovely A-rated homes if we can't actually have people living in them because they keep getting flooded. So we need to build that in as well. So in terms of some of the actual projects that we're doing, one of them is the local area energy plan. So we commissioned this piece of work gathering in information about energy demand and use and opportunities in Belfast. We've never gathered information at the scale across Northern Ireland. We worked with utility providers, every source of data you could possibly get, and a lot of the organisations are here today. And we've found that we've got really high quality data around every building in Belfast now. If you live in Belfast, we've got data on your EPC rating, the measures in your home, but also just the condition of your home, if you've got double glaze and loft insulation. And it means that we've got it on the buildings, but we've also got the socioeconomic information as well. And it means that we're able to do things like the Northern Ireland Federation of Housing Association said, could you produce a map that shows us the distribution of social housing across Belfast and an indication of the energy performance of that stock? So that's what that map at the top is about. And the other diagrams show you how we were able to use it for to identify opportunities for retrofit and low carbon options as well. And I suppose our headline project from that is the low carbon district heating scheme that we've got feasibility studies into that at the moment. We've also got a domestic retrofit programme that we're trying to bring through on that. And we're also looking to, we've got 500 homes in oil that we want to move. So that's one of the projects. Another one, you've got Alan Ritchie here today from C60 Architects. We'd identified that we were missing detail on this really tricky sector to retrofit. So we commissioned them to carry out a detailed retrofit survey of 2 of the private sector's solid wall Victorian rental properties, because we need to understand what are the local challenges, what are the local prices, what are the local materials. And the bottom line on that, and Alan can tell you a lot more about this, is that in some cases you look at buildings and no matter how much money you throw at them, you will really struggle to attain any kind of high level of EPC rating. And the last bit, this is the bit that I'm knocking my pan in over at the minute. This is the really big piece we're working on. It's getting an area-based cross-tenure pilot project, because this is really common across Belfast. We have privately rented social housing, owner-occupied sprinkled in amongst all the rest of it. So we are trying to find a way of, we know that we've got major grant programmes likely to come in 2 years' time, but they won't solve everything. We've found that in GB and the Republic of Ireland. We need to find a way, if you've got a street with maybe 20 houses in it, and some are social housing, some are eligible for the current funding pots, The ones that aren't eligible for funding, they're the ones that are blocking the whole thing from going through at the moment. So we're trying to find a way of bundling them. We're trying to sit down with our partners and work out there must be a solution to this, because even if and when those major funding pots come through, we're still going to have this problem to solve. So we're also working with our partners. Housing Exec have got a very ambitious low carbon homes project, so they've got 400 deep retrofits going on, which are amazing. You might hear about those today. But also the Northern Ireland Federation of Housing Associations, they have an ambition to deliver a more shallow retrofit in 4,000 homes across Northern Ireland. Programmes like this can be the cornerstone to us being able to do a pilot project like this, and that's just a good example of how we collaborate. So just to finish off, if you want to find out more, that's my email address. Don't expect to get anything out of me for a week because I'm on holiday tomorrow. But if you do want to get in touch, you'd be very welcome to come and join the hub. Just drop me a line. Okay, thanks everybody.
Thank you very much, Brenda. I think you'll all agree Brenda has definitely set the context for today, both in terms of understanding the scale of the challenge for our domestic buildings, but also our commercial buildings. So to begin to start to unpack what the solutions to this challenge might be, our next speaker will be Gavin Johnston, who's Retrofit Impact Manager at the Built Environment Smarter Transformation, or BEST. It's more easily remembered as. Before joining the BEST's Innovation Centre, Gavin has worked across the built environment on strategic asset and estate management for both public sector and housing associations. With an architectural background, Gavin is a certified passive house designer, has contributed significantly to the design and refurbishment of numerous public and domestic buildings, as well as leading the delivery and passive house developments across Scotland. Committed to decarbonising the construction and housing sectors, he utilises his knowledge and expertise to support the wider built environment sector to harness the positive impact of the net zero transition and to improve the lives of everyone living in Scotland. Within the Innovation Centre, he is lead project manager, delivering the first phase of retrofit of the BEST's Accelerator Lab, home of Scotland's National Retrofit Centre. Gavin will be discussing the work that BEST do and their Living Demonstrator project, an ongoing retrofit of their Accelerator Lab in Glasgow. Please welcome Gavin to the floor.
That sounded a bit more grandiose than I realised when I sent it across. Yes, so thanks very much for having me. We at BEST, as was said, as Built Environment Smart Transformation, started 10 years ago as Construction Scotland Innovation Centre, which maybe does a better job of explaining what it is we exist in order to do, but CSIC isn't as good an acronym as BEST. So we rebranded as we focused on our mission, which is to accelerate the built environment in Scotland and beyond to net zero carbon. I'll just let this run in the background. We are part of Edinburgh Napier University. We're an innovation centre focused on the built environment, which we see as wider than just the construction sector because of how much it touches all of our lives. We exist as a link between academia and industry in order to support programmes that will ultimately lead to the betterment of that sector. From our campus just outside of Glasgow, we have two factory spaces. One is a manufacturing plant focused on mass timber. The other was mentioned as Scotland's National Retrofit Centre, currently undergoing a retrofit at present. So we're a United Nations International Centre of Excellence for Net Zero Built Environment. As was touched on, the reason that we exist is because of the massive impact that the built environment has on all of our lives and the area where we can focus our energies in order to make maximum gains and impact. We exist not only from a net zero perspective, but also to support the construction sector in Scotland because of the number of people that it employs and the routes into employment from that as well. So as I say, we have our core function is to sit there as an opportunity lab for anyone who wants to try something new to come and test it in a safe space, to connect with academia, to connect with collaborators across, to develop new products, new services, and new ways of working that ultimately makes us all perform better. We deal a lot with upskilling in terms of the workforce as well, so we train people in what would have been called green skills or clean heat skills. We do pacifist practical training. People get an opportunity to get hands-on, and we run a conference every year in November called BestFest, which is focused on 2 days, a general built environment net zero summit, and followed by the International Retrofit Conference on the second day. So we've heard about the domestic market, and we exist within BEST as an impact manager there working on retrofit. We do look at domestic properties when we talk about retrofit with a keen focus, but we're also acutely aware of the number of non-domestic buildings that are going to have to deal with very similar challenges on a completely different scale. But what we've found is that we see that the similarities, questions around funding, knowledge gaps in the existing data sets, understanding what we want to do with building long-term asset management plans, all of that mirrors in non-domestic properties as it does within domestic properties. So as part of the university, we applied to Scotland's Public Sector Heat Decarbonisation Fund, which was managed by Salix Finance on behalf of the Scottish Government, and we were awarded a grant of just under 1.25 million to retrofit our training lab or accelerator lab, where we do our physical training to decarbonise the heat within that building. As being the innovation centre, a kind of core focus for ourselves wasn't just to demonstrate a living lab for retrofit, but also everything else that we did at BEST. So if we take a fairly difficult, complex concept like retrofit, and we make that more complicated as further by trying to include for modern methods of construction and off-site fabrication. In order to demonstrate that these principles in new build could be applied in retrofit settings and to some degree or other help us to accelerate the uptake of retrofit across the sector. What we want to do is we want to have a demonstrator project that is a beacon that people can come to and learn from. It's potentially not going to be a project that you would say a replicable project, but what we wanted was to showcase as many products, services and approaches as we could that could be cherry-picked across the sector in terms of an approach. Our key focuses are delivering the first phase of a multi-phase campus development. We saw this as being incredibly important because anyone who deals within asset management or estate management has to marry their long-term estate investment with retrofit. And how do you achieve incremental improvement without having abortive spend when you're doing works? So how do you ensure that you take it far enough to have a deliverable phase one project, but you've not taken it so far as to lock yourself out of future investment in the building? Ultimately, we intend through this project to achieve the ENERFIT standard for the full building and the new net zero public sector building standard as well. We wanted to maximise our funding opportunity because that's a lot of money to be able to bring in to the university. And it represented 80% of what we had applied for at the point of funding, which I'll maybe touch on later. And we wanted to be data-driven in everything that we did. The core focus of the funding is around decarbonisation of the heat, so that has to be has to be kept true. But we promote a fabric-first approach, so we wanted to reduce that overall demand there. We wanted also to maximise the opportunities, as I said, of other opportunities that we have within our campus, using modern methods of construction and homegrown timber CLT manufacturing processes. We also, from the outset, had decided that we wanted to prioritise low-embodied, homegrown, natural-based materials as far as was possible, and that gave us a benchmark, and we worked through it from there as well. So these are the funded measures as it was. They're split in a kind of a rather unattractive list. That's because this was all of the funded measures at the point at which we applied for funding. Then the funding, as I said, was 80% of the value of these works as listed or as we had anticipated. Unfortunately, the costs as returned after tender were much higher, which I think everyone in the room will be familiar with. So as a result, what we had to do is we had to enter into negotiations with the contractor, and we had to do a value engineering exercise. But we had those core principles at the start to kind of be our kind of North Star and check back against. As a result of the phased approach to works, it led to us de-scoping 2 areas of investment, which was a solar PV array and solid floor insulation works. The reason for that being is solar PV was seen as an opportunity that we would easily deliver as a separate package. It didn't fundamentally affect the energy balance of the building as designed, and was likely to be fundable as a separate standalone piece of work. It would certainly have been cheaper to keep it within the package because you've got access costs, but it was seen as a saving, and we were able to negotiate with the Scottish Government to say that they would reallocate funding in lieu of being able to increase our funding grant value. Exposed floor insulation was slightly more complicated, purely because the funding paid for the measure itself, not the remedial work that you were required to be done. So we had no money for internal works. This was a fabric and MEP project only. So again, what we decided to do was we moved the exposed floor insulation to a second phase, and we've over-designed the walls and ceiling to account for the heat loss that generates, to offset that and still achieve the energy reduction, whilst also having to design in to the system an ability to move all of the doors on the external wall up by the 230mm that we're going to have to work with. So challenges and opportunities of a project of this magnitude, the biggest one being is timescales. Government funding runs on a financial year basis. You are told on the 4th of April that you're successful in your funding application. The funding has to be spent in its entirety before the 31st of March the following year. That included going from stage 1 design to stage 4, tender, procurement, on-site, off-site. So again, not an easy task. Again, trying to marry between scope, what do you include within a phase 1 retrofit, and what do you move to a future phase of development, and how do you ensure that you're delivering across different project phases? How do you drive innovation within a project? How do you manage and mitigate risk? How do you ensure that the story is told? So that's part of what I'm here to do today, is to talk about this, to do, as we refer to it, as a warts and all, because we believe that honesty is key, that there's no point in showing this at the end of the project with the chocolate box and say, it was very easy, it was a turnkey solution to deliver this. And how do we create a platform at best and for our partners to build from? So this is how we've split it. We've done phase 1, which is the current heat decarbonisation works. Phase 2 is further internal augmentation, extension, and final fabric envelope at the front end of the building. And overall, phase 3 is the future whole building being certified under the ENDRFIT criteria. This is a really boring slide, but that's really how boring the building looks, unfortunately. I don't actually have a better photo of it, thankfully, but essentially what we're looking at is the top right, as you see it, is that curtain walling system is essentially where the heated spaces are. That's coming down, and we're trying to turn this into an energy efficient box. And long term, this is what it should hopefully look like. These are the drawings submitted as planning status. But this will not be the building that's delivered in phase 1, thanks to the value engineering, things like your draft lolly, the canopy, that's moved into phase 2. Again, anything that sat out with the thermal envelope was moved into phase 2 to reduce on costs. The design itself is a panelised CLT system with JGI joists externally to give you the depth in order to install homegrown Scottish hemp natural-based insulation material, and it will be clad in, it will be a clad system in 2 different types of thermopane from Russwood cladding, and it will be triple glazed windows, and the ceiling is a suspended timber ceiling detail, as opposed to a new roof to get the thermal envelope there. As part of the project, we looked at the existing building and we measured what its current performance was as best we could. Again, within tight time constraints, it would have been nice to have a full heating season with which to install sensor technology, but we did what we could. We did an air tightness test on the building and a smoke test and stopped counting at 27 air rate changes and just decided to agree that it was pretty leaky. And anything that we would do would ultimately be to our betterment. And again, what we're ultimately trying to achieve is is a zero direct emissions heating system. A lot of these projects that have been funded through this are gas out and a electric based system in. We wanted again to try and push the envelope as far as we can, so the design here allows for a PVT solar system which feeds a augmented ground source heat pump which becomes a water source heat pump, and that does the majority of the building demand. It will be backed up by a 10 kilowatt air source heat pump for the coldest day of the year, and through the value engineering discussions with the MEP subcontractor is continually telling us not to put that air source heat pump in because they're saying that will never ever be switched on. But that's not what the design says. Also, the system itself has to be designed for a to be defined phase 2 extension. So you have to decide how far along the kind of outline sketches you have of what the building footprint might ultimately be to ensure what you're installing now will still work in your future phases. In order to deliver this, we've used and utilised our extensive network and those companies that we want to support, but who also want to support us and help us to deliver that. So we're featuring Kenetec K-Brick as a 90% recycled brick, which is a project that we have featured in our factory for a long time, and a company who we've supported, but now they've only just achieved their BBA compliance, and this will be in a real build scenario as well that will build the plinth design. We've got the Russwood Cladding System, a Scottish-based company, Ecological Building Systems, who support the sector in terms of training around passive house and air tightness products. Rockwell Installation have supported the project, as well as Indie Nature, who provide, based in Jedburgh, provide hemp natural-based insulation. Ecosystems Technologies, who manufacture Scottish low-quality grade timber, homegrown CLT into commercially viable structural Scottish timber system. And that, so if you're using CLT in the UK and it doesn't come out of our factory, it's not coming out of the UK stock. So this is one of those opportunities where we're trying to see how do we scale this up and really make it deliverable, and how can we take it, not only demonstrate from a new build perspective within retrofit. High-6 design here shows the detail in which the panels are constructed for off-site. So we're trying to kind of modularise everything as far as possible, do as much on the factory floor as we can, and come onto site 95% ready. It just so happens that our off-site and our on-site are about 20 feet away from each other, but let's not get hung up on that. So again, this is the testing in terms of, like, I don't know how clear it is, you can see, but really you shouldn't see any of that smoke coming out of that facade system there. And the thermal camera shows you how poor quality the glazing and the curtain walling system was. We've retained all of that. We're very fortunate for space, so we've dismantled as carefully as we can the facade system, and we're looking at options for how we can reuse or move on these materials to be used in further, either a phase 2-3 construction on our site or onto another site as well, to minimise wastage. We have taken the opportunity to upskill. So as I mentioned, the big part of what BEST does is we train people on how to build to passive house standard. And this is the design team, as well as the main contractor and the main contractor's supply chain, undertaking that training together on site to understand the core principles of what we're trying to achieve in terms of that thermal envelope, continuous air tightness line, tight fit of insulation, and again on site as well, the architects visiting the factory floor to talk through with the challenges of fitting the material and ensuring that you're getting minimal gaps, that you've got no overlapping joints in terms of toolbox talks, and upskilling this supply chain to deliver other projects of this scale. As I said, we're very fortunate, and some of the panels we've been able to get hands-on and actually manufacture ourselves, and Ecosystems are very patient with us when we do that. We haven't been able to at this point, but we've just purchased a new CNC machine that's now large enough to process an entire panel as well. So these panels have been planed, filled and cut by hand. Next month, once our CNC goes on, the panel should be able, in theory, be lifted off of the bed and run through, and all of the four edges cut and all the apertures removed within that. So this is where we are just now. In terms of the demolition that we've done, in terms of the dismantling, we're slightly further on than that, and we're ready with our first 2 stages of panels built, waiting for the wind to calm down so that we can lift them into position. And I had hoped today to be able to show some videos of that, but, well, last week didn't happen, and you're stuck with these rather boring photos and me just me talking over it. But this is to give you a sense of scale of the panels. The panels range from 8 metres to 10 metres tall. The depth of the JGI is defined by the amount of insulation that we required. And then obviously we wanted a tight pack and a tight fit. The more eagle-eyed among you as well will be able to see that some of these photos are not as it will be when the door is closed. We have had a lot of work to do in terms of the upskilling and understanding how to work with the material, the time it takes to cut it, the time it takes to fit it. And I don't think it's ever any fitter's dream job to have the client sitting up the stairs and be able to walk down at any time and point things out. But it does give us that higher degree of quality assurance. Yeah, and that's us. Thank you very much.
Thank you, Gavin. And that's been a great introduction to how we might actually start to address some of these challenges, but also a very honest reflection about some of the difficulties along the way. And I know that's a conversation that we're going to continue for the rest of today. So we are now joined by Dr. Craig Robertson. Craig is an architect, a researcher, and a lecturer. He's particularly interested in the relationships between architecture, energy, occupant experience, and the environmental enhancement. In his current role as Head of Sustainability at Riddel Hall, Monaghan Morris, Craig is responsible for developing their sustainability and building performance agenda. He leads on their building performance evaluation programme and develops sustainability-related research and development. Today, Craig will be highlighting the importance of whole-life carbon to make informed decisions in refurbishment and retrofit of all our existing buildings, a topic that is particularly close to my heart, so I'm really looking forward to hearing what Craig has to say.
Hello. I'm just going to stick a timer on to keep me honest. Thank you very much for having me. What a great space to speak in. And thanks, Siobhan, for the introduction. As Siobhan said, I'm going to talk about visualising whole-life carbon for informed optioneering in existing buildings. Long. AHMM, so Alfred Hall, Monaghan Morris, we're a general architectural practice. We work across all sectors, all building types. We're London-based, but we have offices in Bristol, Oklahoma, Madrid, and a small office in Sydney now. We work across all sectors, as I say, new build and retrofit. My role within AHMM, as Siobhan said, is we have an in-house building performance team. We work as a kind of in-house consultancy, interrogating architectural decisions, carrying out analysis across all kinds of environmental metrics to try and understand and improve the impact of the decisions we're making as architects. So what I'm going to talk about today is a tool we developed through a KTP program with UCL, which visualizes whole-life carbon, and we use to interrogate decisions and understand the kind of life cycle impacts of those decisions. But I want to start with just highlighting kind of retrofit. So I've been at AHMM for 11 years, but as a practice, we have thought about reuse and what we now term retrofit of buildings as a pragmatic starting point for any building. This is a T building on Shoreditch High Street in East London. You can see the series of dates on there. We first worked on this in 2003. The competition for this building was to demolish it and propose a new build on that site. We recognised the kind of qualities that are in the space. It's the tea building because it's the old Lipton tea warehouse, beautiful high ceilings, great bones, good daylight. So we recognised the kind of value in that building and proposed keeping it. The series of dates on that show that we've been back to kind of carry out further retrofits. The 2009 project was called Green Tea, which we went and retrofitted and upgraded the fabric, replaced the windows. 2011, we went back and upgraded the environmental systems in there. But it's kind of recognising the kind of historic pattern of those buildings and the kind of architectural qualities of there, which is why we were thinking about retrofits. The Angel building in 2011, again, is another retrofit. It's a quite slick office building, kind of city fringe and Angel in London. But again, this was an existing building. It was an unloved telephone exchange. We recognised early on in that process that the existing frame had good floor-to-ceiling height, good bones again. We could retrofit that. Carbon wasn't on the agenda at the time, so it was about cost and time. We saved the client £7 million in 9 months on programme by reusing that frame. So it was a kind of way, an intuitive way of thinking about that building. We turned the unloved courtyard into this new public room on the right-hand side with what was at the time the greenest concrete. We did a report, 35% PFA in 2009 was quite progressive, we thought. Moving more recent buildings, this is 2019, this is the Borough, this is an old street just along from our office. This is a 1960s tower which was reclad in the 1980s, and then we have similarly reclad it in the 2010s. It is a retrofit. You can see we added 3 floors onto the top of the building. We added some wings onto either side of the building. The existing concrete frame, again, good bones, but had pretty limited floor-to-ceiling height. So the image on the right-hand side shows each of those wings we've added on. There's a kind of double height space on each floor, which kind of interlocks. So each floor gets a double height space on either side. So I suppose I'm showing this because, again, it's a retrofit. It's the second time that building has been retrofitted in its lifetime, but we need to come up with architectural solutions to some of the limitations that exist in existing buildings, and kind of creating these double height spaces allowed us to do that. Final one is one we finished last year, Tower Hamlets Town Hall. This is a listed building, so in this case we're working closely with heritage bodies so that they can understand what we're trying to achieve. We can work within their parameters and constraints, and we can upgrade fabric sensitively to the building. This was the old Royal London Hospital in Tower Hamlets. Tower Hamlets local authority took this building on to build, to consolidate all of their kind of local authority infrastructure into this building. The hospital's been replaced by that kind of PFI monster you can see lurking over the shoulder behind. But the building itself, there's a large extension at the back. But what we also like to kind of investigate from an architectural point of view is taking these historic buildings, this case is a listed historic building, and putting these kind of modern interventions next to there, so we create these moments of contrast and we think kind of architectural delight around that. So a kind of history of AHMM is approach to retrofit as a kind of intuitive, pragmatic approach to how we think about architecture and recognise the qualities that are in those spaces. So then 17-18, some carbon targets come along. We were involved in writing the RIBA's 2030 challenge through my involvement in the then RIBA Sustainable Futures Group and all of the sustainable outcome documents that came with that. They gave us a kind of a quantifiable number to work to. LETI, similarly, their climate emergency design guides, gave us a way of articulating these decisions that we'd be making intuitively, I suppose, and architecturally. It gave us a way of talking about this across our design team in a way that we hadn't before. The UK Net Zero carbon building standard has just been released for consultation, and that has given us a kind of greater range of carbon targets across different sectors that we can use to kind of talk about what we're trying to do with buildings. So retrofit as a kind of intuitive and pragmatic architectural approach has now been kind of given a numerical language that we can talk about. So in 2019, we set up a knowledge transfer partnership with UCL's Bartlett School of Institute of Environmental Design and Engineering, as it was. What we wanted to understand was what kind of, in commercially driven buildings that we were working on. The image on the right shows a building for British Land in Canada Water, which is southeast London. This is not a retrofit. This is a kind of tabula rasa. It's a kind of old industrial site that has been cleared, large master plan. This building was 1 million square feet of commercial space, 600 residential units in 2 towers, and some leisure in the form of a cinema at the time. What we wanted to understand was what opportunities in these commercially driven large-scale mixed-use projects, what opportunities there were for driving a net zero carbon agenda. So we used that project as part of a KTP project to come up with a piece of guidance for delivering net zero in use. Out of that came a toolkit, which is an Excel spreadsheet, a beautiful Excel spreadsheet, I might say, that you can download. I've got QR codes later you can download it from. But this is a way of visualizing whole life carbon based on the RICS methodology that we think is really important and really helps us articulate those decisions in a way that we haven't been able to before, understand the kind of architectural decisions we are making, and interrogate our design teams and kind of push them on various bits of the building that we think we should be working better. And I'm going to use that toolkit as a kind of lens to look at a couple of projects. But I'll just spend a minute on the kind of visualization that comes out of that. I'm going to shout because I'm going to point. So it's based around the RICS methodology. On the horizontal axis, we've got time, so this is practical completion. This is a notional 60-year lifespan and beyond. On the vertical axis, we've got cumulative carbon, life cycle carbon. I'm not able to point this. So this is A1 to A5. So this is upfront carbon in the RICS methodology. So practical completion, A1 to A5. So that stack is all your upfront carbon. Yellow is substructure, orange is superstructure, blue is facade, etc. The next chunk up is B1 to B6. So in use carbon, the orange line is cumulative operational carbon, and the little additional chunks of embodied carbon as we go are the replacement, maintenance, refurbishment rates as defined by the RICS methodology. So your services last 20 years, you replace them, so you get a little chunk of embodied carbon. Your facade lasts 30 years, so you get another chunk of embodied carbon after 30 years. So that all sits in that in-use space. The C module at the top is the dismantling and demolition of the building, the carbon associated with that. And then where we go beyond RICS into the D, along here is a negative number, which is the carbon you can save by recovering materials from this building. So in this chart, you get a whole life carbon number, which then defines what you need to offset. And what we're trying to do with this is to provoke the lowest possible life cycle carbon and get designers thinking about what happens during the life of the building and at the notional end of a building. So setting up for retrofit, essentially, so we kind of have to offset in minimal. So I'm going to use that chart to talk about a couple of other projects as we go. The toolkit interface, as I say, is an Excel spreadsheet. Our graphic designer has done stuff with Excel that I didn't know was possible, and it's beautiful. There's buttons. It kind of opens up and unfolds in front of you. You can download it. It's freely available, and there are some tutorial videos on our website, so you can download this, use it, and start using it. It works on quantum and carbon factors for materials. So I wanted to talk about two projects and then a bit of research. Excuse me. First project is 1 Berkeley Street. So this is West London, and I suppose it's worth pointing out this is on Piccadilly. The building on the left, just poking into the corner, is a Ritz Hotel. So this is a kind of historical space in a heritage context. Westminster City Council. The building on the top left, the picture on the top left is a building as was. The top right was a planning consent achieved by AJ Associates to demolish the existing building, dig a 3-story basement, and build a new building. Our client came to us in around 2020 with a different business plan, who thought that they could reuse the existing building. So the bottom image is what we have done to that building. We've extended it upwards and outwards and retained the existing building to create an office and hotel. So the fact that this is in Piccadilly, I think, is important because it is retrofit in a high-value location. So we're talking about retrofit in a space where you might expect things to be new and shiny, whereas actually the market is accepting reused and recycled buildings. So this is just some call-outs from our Revit model. We've got some retained elements. We did demolish quite a lot, and we did build quite a lot, but we reckon we saved about 4,000 tonnes of carbon just by keeping the frame there, keeping the superstructure, and not digging any holes in the ground. The building looks like this from above. So this is Piccadilly. On the main elevation, Berkeley Street runs up the left-hand side. There's a courtyard in the middle, which is an existing service yard, not doing much. Opportunity for kind of intervention. This is that courtyard on the left-hand side, as it was. It was a kind of underpass through to a kind of usual bit of kind of white van guys, dropping off packages, cordoned off bits, parking for your whatever kind of car that is. We turned that into a new place for people to use. It's got entrances into new commercial units. It becomes another courtyard which sit off the back of kind of the main thoroughfare. In the kind of history of lots of city grain, we green the facade because we've got little opportunity to get our biodiversity net gain into this building, so it happens on the facade. The building on the left, as it was, it's a fine 1960s kind of modernist building, concrete panels, we quite like it. On the right-hand side, we clean up them. We replace the windows, again, in a heritage context. We're talking with the local authority and the conservation officer to see how we can do that sensitively in a way that works with the fabric, with the building, with the area, and with our clients' aspirations. We're extending the building upwards with the hotel, and I suppose a marker of change is on the left-hand side, we've got a Boots pharmacy in the retail unit on the bottom, and on the right-hand image, we've got a Lotus showroom. Don't know if that's a good thing or a bad thing, but it's definitely a thing. I'm just pointing it out for you. So, the building itself, it's got good bones again, so it's a concrete frame, it's got good floor-to-ceiling height. We've saved about 82% of the building by GIA. As I say, we've replaced the windows, we've upgraded the thermal performance of the fabric. On Berkeley Street itself, the facade is simply painted, the bricks are simply painted. We introduced these strips of greenery up the facade to create some biodiversity net gain, and our client had an aspiration to have some kind of explicit environmental qualities around this building. The courtyard, again, is kind of lushly greened. So I want to just poke into some numbers here. So these are 3 charts. On the left-hand side, we've got upfront carbon. The 3 columns are the GLA, the Greater London Authority's carbon target. The middle column is the GLA's aspirational upfront embodied carbon target, and the right-hand dark colour is our embodied carbon target, our achieved embodied carbon value, upfront embodied carbon. The dotted line above is the UK Net Zero Building Carbon Standards value for upfront carbon. So you can see we are about 323 kilograms of CO2 per metre squared for the upfront carbon, A1 to A5 carbon on this project, so much lower than the Net Zero Carbon Building Standard. In the middle is the life cycle embodied carbon, so everything minus B6 operational energy, and again the 3 columns are the same, and you can see we're much lower than the GLA's aspirational embodied carbon at 592 kilograms of CO2 per metre squared. The right-hand chart is operational energy. You will see that we are above both the GLA's target and the UK Net Zero Carbon Standard. This is a hotel with a kind of luxury hotel with high domestic water use. So our operational energy is higher. We could have done better on that. So this is the Excel output of the chart I was showing earlier. You can see a very small chunk of upfront carbon. There is no yellow in here because there's no substructure, because we kept the substructure. The superstructure that we did build on that is quite light. We're at 323 kilograms CO2 per metre squared. The operational energy line is pretty steep on this building, and that's because it is gas-fired. Our client wanted to keep the gas-fired plant in this building, so there's 1,400 kilograms of CO2 per metre squared over the life cycle of the building in just operational carbon. So an obvious way to decarbonise the life of this building would be to electrify the building. The refurbishment and replacement rate chunks in this are as Rick's assumptions, because in this case, we couldn't predict the future. We don't know what our client is going to do with this. I've got some slides later to talk about the limitations of that. This is what happens if we electrify the building. That operational curve becomes flatter, and we half our life cycle carbon. So an obvious kind of design decision would be to do that. Final chart on this project, substructure on the left, facade in the middle, finishes and services. The coloured pieces are the amount of carbon we had in the building. The white pieces are what we think we saved. The blue lines are the Net Zero Carbon Building Standard. So you can see that upfront carbon is saved in the substructure, superstructure and the facade because we kept most of it. The stuff that we are not doing better than targets and finishes and services, because that's all in the life of the building. So we need to think better about how we work the life of the building. A note on circular economy. We used a load of reused raised access floor. I'm highlighting this because it was a total nightmare. Every time I went to site, I got shouted at and sworn at by the project manager because he's finding this stuff at the right time in the right site in the right quantum, getting onto this site. Total nightmare. So I think circular economy is something we need to work on as an industry. Second project, 242 Marylebone. This is a slightly different project, so another reuse, but with a significant portion of extension. We built a load of terraces with some greenery on it, with some outdoor space and amenity. It is in, again, City of Westminster. This is Marylebone Road. If you go that way, you get to Euston and King's Cross eventually. Regent's Park's kind of top right. It sits in kind of almost a whole city block again. It's a Richard Seifert building. So I think 1950, so shortly before the concrete panel salesman got to him, because this is a load-bearing brick building. Portland stone on Marylebone Road and a load-bearing brick facade on the right-hand side with punched windows. Again, an unused courtyard. It was built for the headquarters of Woolworths. It was then operated as an office. This loading bay was very much underused, so a lot of opportunity to reuse that. Fairly grubby, grim entranceway, and the floor plates themselves are nice lit, but didn't offer what our client wanted in terms of kind of their aspiration for kind of the user experience of the building. In fact, our client had lots of, quite a multifaceted brief for us about the user experience and work-life balance in terms of amenity, how they integrate active travel, running, etc. into the building. So they were interested in the user experience and the kind of architectural experience of this building. So what we did, again, we extended upwards, we extended outwards a little bit, we repositioned, we reconfigured the entranceways. Number 3 there is where the kind of main entrance is. But the main move in this building is number 6, so we introduced this kind of terraced set of floor plates into that courtyard. The section looks a bit like this. You can see on the left-hand side, we've got, I get a pretty mean floor-to-soffit heights of 2.56 in the existing building. So in the new piece, one of the focuses was getting some release from that and getting some greater floor-to-ceiling height in the new pieces. The existing building is kind of the top 2 floors are new, so the existing building's on the left-hand side. So again, our load-bearing brick building with lots of little cellular spaces in the middle, we took out a lot of that space and replaced it with columns. We saved, I think, 95% of the existing GIA. Again, we had to strip out quite a lot of the building, particularly on that back elevation. We had to take the facade off so we could rebuild that extension. We think we saved about 3,500 tonnes of carbon by keeping the structure. We wanted to keep the bricks. More on that later, but the structure looks like this. So we've got the existing building in grey, we've got a new steel and CLT structure on the side and on the top, driven by the carbon for a steel and CLT superstructure was not that much lower than a steel and metal deck and concrete structure or a concrete structure, but where the savings were in the substructure because the steel and CLT was a bit lighter, so we saved a lot in substructure, but no, we have dug a new basement in this case, so we're kind of adding to our carbon footprint in doing that. The terrace looks like this. We get, excuse me, every floor plate gets an external space. With soon-to-be lush green terracing around there, which delivers our biodiversity net gain, but also gives people some access to some biophilia and hopefully some place of respite as per our client's aspiration. Excuse me. And we also upgrade the entranceways. The green element within this terrazzo was a crushed part of the existing structure that we thought we could build into that and have some kind of nods, some visible nods to the kind of to the reuse of the building. We cut an atrium through the building to get some daylight into those newly created deep plan floor plates, but also to give you a view out and some drama to the entranceway because the existing entranceway didn't have any of that. And then the new floor plates, as I said, we were looking to have clean, high floor to ceilings as much as we could within the constraints of the existing building and marrying through to the existing floor plates. Our client was interested in the kind of the architectural experience of being in these spaces. So what the CLT and steel gives us is a really clean soffit, all air and is delivered through the floor. We have minimal servicing on the top of that, so there's less stuff to rip out throughout the life of the building. And we get this, nice clean floor plate. Numbers. So same charts as the previous project. On the left-hand side, we've got upfront carbon, A1 to A5, again compared to the GLA target and aspirational target in UK net zero building standard. So you can see we are about at the GLA aspirational target in this case, and that's because we've dug a basement, we've built a new structure, we've built a new building alongside the existing one, but because we've kept so much of the existing building, the kind of carbon intensity of that is sort of diluted across the GIA of the whole building and gets us just underneath the net zero carbon building standard. Similarly, for whole life carbon, we duck just under the GLA's aspirational number at 735. Sorry, the resolution's bad. My eyes are even worse. So yeah, 735 kilograms CO2 per meter squared. And then operational energy, we're around about net zero carbon building standard as modelled. So we need to go into this building is due to complete next month. So we will get into the building, do some post-occupancy evaluation, see how much energy is actually used in this building. But as modelled through a TM54 process, we think we're around about at the right place. Our life cycle carbon chart in this case looks like this. You will note we have got a much bigger lump of upfront carbon with a load of yellow this time because we've got a basement dug, we've got some substructure in there, we've got superstructure, we've got a load of facade this time because we've had to rebuild that facade. We've created a load of new facade in that terraced building. Operational energy number is an all-electric building, so it is relatively flat. There is a slight curve in that because our model takes into account the planned decarbonisation of the grid, so that is why there's a curve in there. And then again, the reuse elements are as per the RICS methodology, so we're making assumptions based on how this building is going to be retrofitted and reused over its life to kind of inform how we decide, but we don't know that. Other numbers, substructure on the left, superstructure in the middle. Again, the coloured pieces are what we've spent in terms of carbon, and the white bits are what we think we've saved by keeping the existing building. So we think we've saved a lot in the substructure and superstructure, a bit in the facade, but again, finishes and services over the life of the building we're not sure about, and we don't know what we've saved, if anything. A point again about circular economy. So throughout the construction process, our contractor has been reporting all of the kind of materials they're using, all the waste they're creating through a dashboard for BREEAM requirements and others. You can see the central bit there in waste, 100% diverted from landfill, which is great. A load-bearing brick building, we were taking a load of bricks out of this building, we were creating a load of new facades, we wanted to reuse the existing bricks, divert them from landfill on site, reuse them. So the raised access flooring in the previous project highlighted the difficulties with supply chain and timings. This project highlights the difficulties of insurance policies. So we couldn't get anybody to insure reused bricks on site, so we've had to give them away to somewhere else. They're sitting in some reclamation yard for somebody's house extension rather than being able to use them on site. And we had to go and buy some new bricks to match the ones that we had on site and we were throwing away. So something for us to work on is how we ensure kind of reclaimed materials. Final thing I wanted to talk about was a piece of research, kind of speculative research we did called Fit Out, Rip Out. This is about fit-outs in commercial offices. It is relevant to retrofit because it's about how we set up our buildings for retrofit. We do lots of commercial buildings. This happens to be a new build. We spend time setting out our Cat A fit-out, our services. There's acoustic rafts in this building, and frequently when we go back to them after tenancy, we find a mangled pile of metal going in skips shortly after they've been occupied. So what we wanted to do was to understand what is happening in the use of our buildings, commercial offices in this case. How often is this sort of thing happening? Is that reflected in the RICS methodology, and what were the carbon implications of this, and therefore how we can use our visualization to help drive architectural solutions to minimize life cycle carbon? We did that by using 4 types of buildings, all current AHMM buildings. We called them a substantial fit-out, which is a kind of full ceiling, hanging below, full services, lights, fan coil units, etc. We called a significant in the bottom left, which is exposed services but with acoustic rafts, etc. Slender, which is lighting, air delivery above, and then the subtle, which is our office in Bristol, actually, which is the cooling is embedded in the slab, air is delivered from above, minimal finishes, minimal fit-out, less stuff to chuck away. We codified these things to understand what elements of those Cat A fit-outs are baked into the building. So, for example, in the subtle version, the cooling coils are in the structure of the slab. You can't take them out. They're in there. They're baked into the building. Whereas in the substantial version, it's all hanging from the ceiling. You can rip it all out and chuck it away if you wish. And that's what we see happening time and time again in our projects. So we then accounted for the carbon in each of those Cat A fit-out versions and classified it by what's at risk. So above the line is what's at risk, i.e. what can be ripped out of the building, and below the line is what is baked in. So in the substantial version of the 78 kilograms of CO2 per metre squared just in fit-out, we reckon about 45 kilograms of CO2 per metre squared is at risk of being ripped out every tenancy turnover. Whereas in the subtle version, the 58 kilograms of CO2 per metre squared that exists, we think only 17 are at risk of being ripped out every tenancy cycle. We then used our tool, our life cycle carbon tool, to analyse what actually happens in typical commercial offices in London, a particular segment of London, a particular size of offices, which said that the average tenancy is 5.1 years, and on average, every third one of those tenancies is rolled over. So you've got, on the horizontal axis in time, we've got our upfront carbon for the Cat A fit-out, and then we've got the RICS standard, the RICS assumed refurbishment and recycle rate, which assumes everything exists in the building till the end of its service life. Whereas what we found what's actually happening in the building is there's this kind of rhythm of tenancy turnovers, which is a 5.1 year tenancy, which First is all often doubled, so it's 10 years, and 5 years, and 10 years, and everything that's at risk in the building getting ripped out every one of those times. So your life cycle carbon of a fit out ends up being like 470 kilograms of CO2 per metre squared, whereas RICS assumes it's 189. So there's a load of stuff in the RICS methodology which we aren't getting accounted for. And through this visualization, we can see that, and we can interrogate our designers and our design teams and our clients and our tenants to challenge them and what their practices are for kind of dealing with their kind of cycle of fit out and rip out. If we look at the subtle version of that, which is when we bake in as much as we can into that fit out, we can see that the same tendency rhythms, the same patterns of use end up with much less being ripped out at the changeover of a fit-out cycle, so much less carbon over the life cycle of the building, but still nearly double what RICS is assuming. So in terms of our life cycle and setting up our buildings to be retrofitted in a sensible way, I think we've got a lot of work to do about understanding how buildings are used and how we can design spaces to be easily adapted. So we want to go from something like this, which is your traditional building. This is one of our buildings, so no implicit criticism of the notion, but a lot of stuff hanging from the ceiling, a lot of stuff, carbon resources hanging from the ceiling. So to something like this, where there's less stuff to be ripped out, less stuff to be chucked away. So what we're trying to do as designers up front in new builds and in how we retrofit buildings is facilitate future retrofit in a low carbon, low resource way. So what's next? So I think there's, I think we can challenge the market perception around retrofit of buildings. I've shown you a building in a kind of sort of high-value bit of London, which maybe wouldn't traditionally go for a recycled building, so I think the market is shifting. I think we've got a lot of work to do in circular economy, so I think in supply chain and timing and storage of stuff and accessing things and how we ensure materials for reuse we need to get on top of. I've talked about carbon and decision making and how we're using this carbon visualization to inform and articulate decisions, but of course it's not the only thing. Lots of other aspects are coming into our decision making about architectural quality and the kind of character of those spaces. So carbon is one parameter of many. I'm sorry, I can't read this. I forgot what it says. I suppose the other caveat is retrofit is not always possible. I think we need to keep that on the table. The retrofit is not always a possible option. We have some sites where we are knocking down buildings, and it's because the existing building is not of good enough quality to keep. So retrofit, while it is the aspiration, it's not always absolutely possible. The final point about wider industry buy-in, I think that goes across our tenants, our clients kind of buying into how these work, but also all of our kind of legislative and statutory bodies kind of buying into what we're trying to do, understanding the carbon implications of keeping buildings and kind of releasing us from some of this kind of straitjackets of what we can do with historical fabrics to allow us to sensitively upgrade things in a way that helps with the kind of whole life carbon agenda. I'm going to stop there, and I'm going to leave these QR codes on there so you can download stuff, or you can just go to AHMM's website and you can download all that stuff if you wish. Thank you very much.
So thank you to Craig. Some really interesting case studies there, some examples of what can be done and what is being done. But also I find the last set, the rip-out section, slightly terrifying. But good for us to know and really important to learn those lessons. So next up, we're going to be joined by John Casey and David McKelvey from CORA Consulting Engineers. John is the founder and managing director of CORA and has over 30 years' experience developing innovative and creative structural engineering solutions for clients across all market sectors. John's approach is to work closely with architects, clients and industry partners to seek continuous improvement in designs that add real value at the earliest stage of any project. He has spearheaded CORA's many award-winning projects and built an organisation that works at the highest level of engineering excellence, and in recent years is particularly interested in low embodied carbon design of buildings. He was appointed an Irish Green Building Council Building Life Ambassador in 2024 for his work with the IGBC. Today, John will be joined by David McKelvey, who qualified in 2018 in civil engineering from Queen's here in Belfast. He was first introduced to embodied carbon while at Queen's and has brought this knowledge with him into industry. He leads CORA's various embodied carbon efforts across numerous different jobs and clients, ranging from small domestic builds to large commercial projects at Dublin Airport. And David currently heads up CORA's North West Regional Office. John and David will be discussing their experiences in delivering the Google Treasury Building renovation and extension in Dublin. And this project was pioneering in its approach to low carbon design and circular economy principles. So I ask you to join me in welcoming first of all David and then John. Thank you.
Hi everybody. Yeah, so I'm just going to give a rough rundown on the project, the history of the building, and then some of our low embodied carbon and circular economy principles that we use throughout. The second half, John will come up and speak more in depth about structural steel reuse throughout that project. Okay, so the Google Treasury Building was initially built in the 1940s, and it was called Boland's Mill. It was initially a bread factory. We were lucky, we got to see a few photos of how it was constructed. Really useful when we're looking back and trying to renovate the building as to how it was built, what materials were used and how they were used. On top of that, we also received, we were really lucky to obtain these. These are the working blueprints for the construction drawings here. Didn't realise until recently, but it was actually a Belfast architect that was involved in the 1940s, based down near Castlecourt there. Things were done really differently back then. You'll see on the left-hand side, that is the signature from the contractor confirming receipt of the drawings. Not something that's done today, but on the right-hand side, yeah, some things never change. Looking at the time, being very urgent. The building remained largely unchanged for about 40 years there until the 1980s, where Henry J. Lyons came along and designed a horizontal extension. Something that's quite funny here, if you look in both photos, the same white Renault is parked in the same place. Not sure how this has worked out. Yeah, we also obtained the record drawings for that extension as well. And that allowed us to create a Revit model of that 1980s extension. John will speak about this a bit later, but yeah, this became even more important as our project went on. Building remained unchanged then for another nearly 40 years, up until our project began in 2022. Received a bit of media attention back a few years ago for being the home in NAMA. Probably unwanted media attention, but media attention nonetheless. AHMM are a familiar face today, with Craig speaking earlier. Thanks to Craig for not stealing our thunder with this building earlier on. But yeah, proposed project was a 2-storey vertical extension and horizontal extension as well, getting rid of that atrium out the front. You're going to see a bit of crossover between some of the AHMM principles that they've used previously, raised access floor tiles, brick reuse, stuff like that. Okay, history of the project done. So in now to more embodied carbon design. Just worth noting throughout this, we've been talking about embodied carbon for a long time now. But this presentation is nearly all photos, similar to Craig and Gavin earlier. This is, like, we know what we have to do, we know what we can do, but this presentation shows what we're currently doing and what we have done. So this project currently on site, due to finish over the next few months, I think, hopefully by June. Before that, just emphasising why we're even bothering to do this. So, overall building's footprint, roughly about 50% of it is cradle to gate, so on materials that go into the building of that structure, of that building. So, if we can improve our building methods, material use, it's not a drop in the ocean. We'll make significant improvements in the overall embodied carbon or the overall carbon footprint of the building. Before getting into the design, before getting into what materials we're going to use, anything like that, we wanted to interrogate the brief with the client, with the architect. If you're to design a building, especially in Dublin, in London as well, you design for 4+1 allowable live loading. You don't question it, that's just what's done, it's what everybody does. This is well in excess of the Eurocode. where in the south it's 3, I think here it's 2.5 plus 1. All we were asking was, please reduce the allowable live loading on the building. We're not asking for anything in excess of Eurocode, just let us design to Eurocode really. We took the opportunity here, the client is Google. There's a high likelihood this won't be the last building that they build in Dublin. We're hoping that they'll carry this on throughout future projects. So it might be a small difference here, but if this maps out across any future buildings that they do, it'll be a big improvement. Also, there is reluctancy out there to be the first person to do this, the first client to do this. There's hesitancy with, like, will our tenants accept a building that's not 4+1? Our hope here is that they'll look and go, if it's good enough for Google, it'll probably be good enough for us too. Okay. One of the big selling points we used to convince Google of this was down below is a multi-storey car park, which is designed for 2.5 plus 1. I think your office is going to be okay. Onto some material reuse here. So quite early into the project, or I think this was being set up. So taking the opportunity here to just let you all know about this platform. So the Irish Green Building Council have a platform out there called CMEX. For all intents and purposes, it's a virtual or an online salvage yard. If you have large quantities of construction material or any quantities of construction material that you can't use in your own building, please take the opportunity to put it onto this platform. It's all free, in the hope that somebody else might want it and be able to take it off your hands, once again stopping stuff from going to landfill. So on this, there was 500 metres squared of granite on the facade on that 1980s extension. Rumour has it, handpicked from Johnny Ronan himself in Italy, brought back. So this is 40 mil thick granite. We took the opportunity here to stick this on the CMEX platform. So this was all carefully taken down and stored across 55 pallets and 500 metres squared of it, so it's a significant amount. Just over the last few weeks, received word that 100% of this has been reused. A lot of projects around the country, in small quantities and big quantities, all over. You don't have to take the whole thing, just take some of it. So 100% of that didn't go to landfill. Similar to Craig's previous project, we reused the bricks. Didn't have the same insurance issues that Craig encountered previously. Now, this is quite a labour-intensive effort to save materials, but once again, stopping stuff from going to landfill, trying to salvage as much as we can, clean it, and store it on site to be used back in the building. I'll speak later about most of the concrete, but some of the concrete we couldn't cut out. It had to be broken out. In that case, all our reinforcement recycled. Another one that came from Craig's AHMM presentation as well was the raised access floor tiles. Now, we did not have the same pushback that he had. Horizontal elements in buildings contain most of the carbon. If we can make a saving on the horizontal elements, we make huge savings here. By saving the raised access floor tiles on this job, approximately 5% of the building's carbon was saved. Everybody's delighted here, except for the raised access floor supplier. We don't have exact figures on cost here, but I think there's a misconception out there that low embodied carbon design is going to cost everybody money. We've done this previously in another job in Dublin where the client saved €1 million by just saving the raised access floor tiles. Like that, nobody had any issue on the design team of doing this. The contractor actually asked us if he could clean them in place before lifting them, storing them, and taking them back in. I think we're all guilty of working on jobs where the raised access floor tiles have been scrapped, and then a few months later, lorries of it come back into the building. This is it just been stored on site. Like that, it's very important that this stuff doesn't leave site either, because that causes further implications. The bulk of the concrete, what we could cut out, was cut out in sections, lifted onto lorries and taken off-site. Now, we're extremely limited in the south as to what we can do with recycled aggregates. One of the only methods that we could do that was to put it through this company called Greenstone. So we used Greenstone, we took it off on lorries to Greenstone, they crushed it, and then they're certified for using it in some very limited civil engineering applications. But once again, we stopped this concrete going to landfill because the vast majority, nearly all of recycled or concrete that comes off site goes straight to landfill in the south. So this was a big saving. Getting on to some of the new structure then. Like we said before, horizontal elements are your big savers in terms of carbon. We used the lightest weight floor we could in the form of metal deck. And to try to reduce as much carbon as possible in that concrete, we went to 70% cement replacement in the form of GGBS. Anticipating pushback on this, because the more GGBS you use, the slower your curing times typically. There would be pushback in terms of programme. To try and avoid that pushback, this was put into the specifications, put into the tender documents from day one. So every contractor that was tendering for the job knew this was the case. The successful contractors, and definitely the ones who performed best in the tender process and in the tender interviews, were the guys that had no problem with doing this. Some of the unsuccessful ones actually suggested as a saving to try and reduce this to zero, which just wasn't an option in this case. A few years ago, we started to get interested in where our steel is coming from. Not really aware of the actual differences. I think John is going to present the differences as to where your steel comes from in terms of embodied carbon and the savings that can be made there. More just by questioning fabricators, where are you guys getting your steel? So in terms of their manufacturing process, whether that's blast furnace or whether that's electric arc, there's huge differences in carbon, but also on the scrap content used in their manufacturing process. So one of the big companies in Europe is ArcelorMittal. They have various plants throughout Europe, but you'll see there on the first table on the left the massive differences in recycled content from each plant. The first one being a Polish plant where less than 5% of their steel is recycled, versus the two highlighted ones there, one in Luxembourg, one in the Basque Country, where you're well into the 90%. Like that, John will show you the actual difference that makes. So in our specifications on this job, we specified that it needs to come from these plants, so that it can't be written out again, just to ensure that we're definitely getting the scrap content that we want. Coincidentally, one of the fabricators during the tendering process produced this EPD document from ArcelorMittal, who were obviously getting similar queries to what we had, and actually put a trade name on the steel coming from both of those plants and called it X-Carb steel. So the exact same steel, just with a trade name now and an EPD to follow. So rather than having to write the specific plant into your specifications from now on, we can just specify X-Carb steel. So I'll leave you with this. So this is a drone shot showing our X-Carb steel, the 2-story vertical extension, and all our metal deck ready to be rolled out. Thank you.
Thank you, David. Thank you, David. So I'm just going to continue on the presentation here and to talk in a bit more detail, a few more facts and figures. The big thing that we were trying to do on the project to create low embodied carbon impact on it was something we came across in 2019, which was an idea that we had about trying to reuse structural steelwork in buildings. So when this building came along, we had previously found this particular Steel Construction Institute publication, P427, which was about the reuse of structural steelwork. And we went about trying to use that on this Treasury building reuse. So a quick summary of what it's about. This document was written that it was intended to be used for the steelwork of unknown provenance, which was effectively steelwork that people had in stockyards that when CE marking came in, it didn't have CE marking and they couldn't do anything with it. So it was written by a technical committee from the SCI, and it's a really well-written document. It's very practical. So it contains things like you only use post-1970 steel, because before that material factors of safety weren't as evident or not as consistent. No bridge steelwork or anything that had been subject to fatigue. It was also intended for steel to be salvaged and possibly stored and reused at a later date on another site. Now, this was the big thing associated with it. If you follow these processes, which included testing and provided a lot of guidance associated with testing on it, what you could do is you could give that steelwork a CE mark in accordance with BSEN 1090/1. So that effectively meant it's as good as new steel. Now, it's pretty close to new steel. There's a couple of things if you're dealing with compression members that you just look at in the clauses, you know, that are a bit more conservative, but in general it doesn't make any difference. So with this in mind, we set about working on the project to see where we could reuse steel. So as David was saying, we modelled the whole building in Revit anyway in the first place. So what we did is we had an existing model, we had a new model. These are extracts from the new model. On the left you have a section where the lower section you can see in light green is the existing structure. There were some setbacks that were originally there that were moving out, and then you can see the blue structure is additional new steel associated with it. Revit is even a bit limited these days. It has one colour for demolition, would you believe? Unfortunately, we didn't have a colour for reuse yet, so we'll have to get onto AutoCAD to get them to write that. But we used it to the best of our ability associated with it. Revit was really good because out of that we were able to create a whole set of drawings. What you can see here on the drawing is you can see on the table, the light green section on the right is the table we had for reuse of steel. This is the atrium section and just a blow up of it there, where you can see the sections there, which is small but quite important, where we reuse steelwork. So we've identified where that came from and where it's going. So this had a whole back engine behind it in terms of this live spreadsheet that we developed, which wasn't Excel, it was a Google Sheet, of course, because the client was Google. And so various people had access to it, from us to the design team, the fabricator, the contractor. So at any stage, anyone could input into this Google spreadsheet and actually define where the steel was, the condition of it, and what was happening with that steel. So as we started on the building, so this is a shot from the outside, which you've seen before, where's that stone that we salvaged for reuse, and then inside the atrium looking up here on the right. And then as we started to dismantle the building, we had already identified where all this steel was going, so the contractor carefully took it down. So here we are taking down the transoms associated with the two central columns of the atrium there. We specifically told them not to cut back the joints and that on site, and even afterwards we didn't want them cut back to the bare metal where it could actually damage the parent body of the material. On the right hand side there you can actually see some of the steel columns. The pair of steel columns that went full height in the atrium have just come down with their plasterboard lining coming off, just been inspected there. And then we had a whole referencing system that all went back to the spreadsheet. So as soon as the member was taken down, you had this referencing system, MB level 1, and then the member size. And that followed the steel member all the way along, so you could see it where it went as it was taken down and where it was going to. So you can see the steel is going straight on the back of the truck there and just going out the door down to the steel fabricator's yard. So we spend a lot of time identifying where this would go, and that's what you see on this model here. It doesn't look like too much here on it, but what we did is we took steel that we knew, and what we did is with the contractor, we spoke and looked at his program of what he was doing. So what we tended to do was take steel from lower in the building and relocate it higher in the building so that he had time to bring it to fabrication and then bring it back. So here you see it as they started to clean it up on the process. These are the transoms, and this is it down in the steel sock holders. On the left you can see some lovely 254 UCs that came from a mezzanine that was there before, which is just absolutely perfect for reuse. And you can see the circular hollow sections there just waiting in the fabricator's yard. And this is some of the steel work that's actually been put back. These are channel sections that were in the facade. These are the ones I showed you in green earlier on, the B61 stars, saying they're going back to Google. In fact, I spoke to the fabricator last week just about his quantity of reuse in that, and he said, on those channels, he said, I have 100% reuse. I have none left. I've used them everywhere you asked me to put a trimmer in, even when you didn't have it on the drawing, you know. So it's been hugely successful for this. We did have one very large beam that was set back, which is this one on the left. That used to exist about 2 meters to the right. And what they did there is they did put the props up, they did bring it to the fabrication shop, and they brought it back while the props were up. But that was unusual enough. But that was our biggest beam on it, so we saved 3 tons of steel alone on that, you know, so with its associated embodied carbon. So it proved quite successful. On the left-hand side here, you see in the lighter shade of grey here, you can see the trimmers. That again are reused steel. And on the right-hand side, what you see here is the circular hollow sections. What effectively happened there is those circular hollow sections that have been raised up 2 stories. The wall thickness needed to be increased at the lower level, so what we did is we took down the original ones, sent them to the factory, they got new flange plates on them, and then they went back to site, but at a higher level, but effectively in the exact same location they did exist in before. So there was nothing wrong with it. Some parts of them were tested, passed the test, as like it was going to be new steelwork. We knew exactly where this has been for the last 40 years. There was no issue with it. And now just to give you some figures on it, just actually before I do, actually what to mention, that in terms of cost associated with this steelwork, the cost that our client was charged for reuse of steelwork was actually lower than the cost of the new steelwork. It was only about 10% lower. I was disappointed with that, but I think that was actually associated with that they were just they were going into the unknown and they priced for risk. But in fact, the reuse of steelwork was cheaper than new steelwork. So that's a significant factor associated with it. So not only did we do the right thing by reusing steelwork and get low embodied carbon figures out of it, but it cost the client less money. It cost us a lot more time and effort, but we were doing the right thing. So here's a table just comparing the different types of steelwork. So on the left-hand side, you have blast furnace steelwork, virgin steel that would have come from Port Talbot, say, in Wales, which is closed now, and that's, say, 2,520 kilograms of CO2 equivalent per tonne. Electric arc furnace steel, it varies by the scrap content. So take that example of the one that David showed there as ArcelorMittal. If you just actually used a kind of a average figure across the way, you would get vary between 842 and 1,200 kilograms of CO2 equivalent per tonne. And then the X-Carb figure, which is much lower, where they have upped the scrap content even further according to the EPD, and they're also using renewable energy. And their EPD is given figures of 333 kilograms of embodied carbon per tonne, and we're using that. And also going back to cost on that, X-Carb steel is more expensive, but it is only 30 euros a tonne more expensive, is what the fabricators are telling me about that. So it's not a significant difference in cost, but it is pushing the fabricator, it is pushing the manufacturers that way. So it is the only one available now, but there are other low embodied carbon steels coming on the market from other suppliers soon. So it is something we should all be specifying, and as specifiers, when you specify these things, the manufacturers sit up and listen and start investing in different areas, you know, to match what the supply is saying. And the last one here is the reuse steel. So from some research that was done in London by a UK firm of consulting engineers who spent a lot of time looking at transport, cutting welds off and rewelding and that, they say it's approximately 50 kilograms per CO2 equivalent per tonne for that steelwork associated with it, which if you take the absolute extreme, it's a 98% reduction on blast furnace steel. So it's a really, really significant change on it. So one of the things that we try to do on this building is that I have to say personally I'm not interested in LEED or BREEAM. I don't really believe in them as a structural engineer. They deal very little with embodied carbon. I'm not interested if there's a water cooler on the floor plate or not of an office. It doesn't mean any difference to me in terms of what we do. So that's why I was really pushing. I pushed, and Google, I have to say, was a fantastic client to have, because every time I suggested something, they said yes, yes, yes. It might be different now. Money's not as plentiful as it used to be. But we suggested going with this International Living Future Institute carbon target, which was just purely about Module A embodied carbon, not to exceed 500 kilograms of CO2 equivalent per metre squared, and Google agreed to go with that. So we had a pure embodied carbon target, nothing to do with anything else to do with LEED. This I should have spoken to Craig beforehand about his graphics, and so I like a good spreadsheet, but this is what I came up with, you know, so maybe I'll change this for the next conference, you know. So these are the basic raw data figures. I'm an engineer, come on, this is what we do, you know. So stages A1 to A5, the target from the ILFI was 500, but our actual as of last week was 207 kilograms of CO2 equivalent per metre squared. For stages A to 7, or A to C, that's the benchmark which has come from LEED, I understand, of 843. Now, Craig mentioned some GDLA benchmarks, which are about 590, really. So we're actually at 461 for that. So we're below that as well. We have substantial reuse of foundations. We have a few extra foundations in there. It's just a few mini piles here and there where we had some pile caps we need to strengthen, but they're all mini piles. And then put that in context, our AI 2030 target 750, our IBA target 750 as well. Now Letty has a range, you know, like your range. Probably 750 is about a D rating associated with Letty. So we're really happy with the figures we've got, 207, and just one of the things David started with when you're doing a low embodied carbon design for a building, it's not about trying to achieve savings in just one location. It's about chipping away slowly at lots of different places along the way, which is how we've achieved that figure. So the steel has made a substantial difference in it. Raised access floor tiles, as David says, anything that's a large horizontal element. So we have made substantial savings from steel reuse. The X-Carb and the 70% GGBS as well has hugely lowered the amount of embodied carbon in the building associated with it. So in summary, that would be raised access floor use, 95% of the tiles reused. On the reuse, anything that had mechanical damage, anyone had cut a hole in it, anything that was damaged, there was an issue with it. Separately, we had a totally different experience to Craig on reuse of tiles. I spoke to the guy laying the reused tiles last week, and he had no problems with them at all. He was absolutely quite fine with them, you know. It is worth pointing out, you just reuse the tile, you don't reuse the pedestal. The pedestal gets damaged when you try to take it off because it's glued down, and that goes for complete recycling anyway, it's all metal. The GGBS in the concrete is substantial saving as well, 340 tonnes there. The raised access floor tiles, 90 tonnes. X-Carb, 1,411 tonnes. And the reuse of steel sections, 85 tonnes in total, is what I understand at the moment. We haven't quite finished it. We're still doing a few bits and pieces with it. That's why I was asking the fabricator there last week, how much have you left? And he's literally saying, I've hardly anything left here. You know, I've just seen, we brought everything to do with the PFCs that were in the facades down, and he said he's just reused them absolutely everywhere. He's delighted. It's free issue steel for him. You know, he's making a fortune out of this project. You know, so I'm fine with that. You know, we're trying to do the right thing. So just a final couple of slides associated with some of the things we learned on our journey on the way, which might interest you. So down south, we have our technical guidance documents. So approved document D, we call it, and then the equivalent up here, which is the technical booklet B. And I just want to do some comparisons between the two. When we talk about, so on the left-hand side again, the one in the Republic, it talks about the use of proper materials, and it basically says that materials should have a CE marking, or then it goes on to talk about an appropriate harmonised standard, or ETA from Europe, or an Irish Agreement certificate, and we're allowed to use any of those. The Northern Ireland one talks about CE marking as well under the construction product regulations. And when you go into more detail on the construction product regulations, it actually says very simply, in order to comply with the construction product regulations in Europe, your product must have a CE mark to allow its general sale. Now, the steelwork we reused on the Treasury building, we started on our journey wanting to have CE marking for a number of reasons. One of them was we absolutely want to be completely clean and have a complete audit history of the steelwork in case building control ever asked a question about it, or in case anyone ever asked a question on it. So that's why we went the route of CE marking. But it also turned out we never needed CE marking in the first place to comply with construction product regulations, because we weren't selling anything. You know, we weren't putting anything on the open market. And the reason I bring this up is this is a really important fact when you're thinking of reusing materials. You know, according to our guidance documents, knowing is saying we need to have CE marking. You know, we are able to reuse products, and that goes on to further sections in the documents. So in the Republic version, it's actually a lot clearer. It talks about, on the left-hand side, tests and calculations carried out by an accredited laboratory showing that the material is capable of performing the function for which it's intended. That's exactly what we need. That's what you want to do. See there it says performance and use, that the material can be shown by experience such as in use in a substantially similar way to an existing building to be capable of enabling the building to satisfy the relevant functional requirements of building control or building regulations. If that wasn't in the building regulations, I'd be lobbying to get it put in. It's perfect. It's written for reuse of materials. The Northern Ireland version is not quite as clear, and this version is actually exactly the same wording from the English version. I didn't look up the Scottish version, sorry, Craig, but it might be slightly different. You always do things slightly different there. But it starts by saying where there is no relevant harmonised European standard, tests, calculations or other means may be used to demonstrate the material can perform the function which is intended. So it's not quite as clear as the Republic version, which just says straight out tests and calculations if you can prove that. But yet the next section where it says past experience such as in a building in use may show the material is capable of performing the function for which it's intended. And that's the one you should jump on to do with how can I reuse it. Steel is very easy to define. We look at it, we know it's a 203 UC, we know it'll work. But yet we went through a fully recognised process to make sure it was actually capable of doing what it looked like doing. That's a lot trickier with a brick, with a block, with a piece of precast, you know. But it's available for us to do it there. We're looking at other projects at the moment where we're using 140-year-old timber. Everyone signed off on it. It's great. You know, it's well capable of doing its job, and it's been in a dry environment for 140 years. There's no reason why we can't keep using it. You know, we don't need to throw it out just because it's old. So I just want to finish with just a couple of slides of the project, where we were. This is the horizontal extension going on. In the background, you can see the 2 stories that are going up on the building there. You can see the metal deck, and you can see the way that the new floors are going on with the composite metal deck. This is the first facade panel going on, unitized facade system. This is a southern elevation here, so there was a lot of light going to get in, so you can see the shelves there to try and reduce thermal gain and that, so to keep the running costs down. Sorry, I haven't mentioned anything about operational carbon and use, but it is very efficient, I tell you, and there's a lot of rainwater harvesting happening here as well for reuse and flushing of toilets associated with it as well, but that's not really my area, except we had to create the tanks to collect it all. This is a view from up above. It looks remarkably similar to the drawings, thank God. So this is the atrium going up. This is the southern facade. It's on a very tight site. And this is the southern facade going up. And this is the roof light that went on. The oculus went on about 3 weeks ago here. So it's kind of, the atrium is weathered now, technically. As of the meeting I had yesterday, they announced it officially. And this was a photo I took on Friday of where the building is now. And I'll finish with that. Thank you.
So thank you to both David and John. There are some very encouraging examples of how we can reuse materials, how we can optimise design as much as possible, how we can use recycled elements within a building to reduce the carbon footprint and reduce that embodied carbon. So I'd like to invite our speakers, Brenda, Gavin, Craig, John and Sharon, to join me at the front here for our panel discussion. And while they make their way up, I'll introduce Sharon Poots, who will be joining us today for the panel. Sharon is an architect and senior project manager within the Northern Ireland Housing Executive. She specialises in domestic, educational, commercial and conservation works. As a senior project manager, Sharon has worked directly on a variety of both new build and retrofit pilot projects to investigate innovative methods of construction along with sustainable active systems. Her portfolio of projects includes the first new build scheme for NIHE in over 24 years, which investigates modern methods of construction along with ultra-low energy building techniques. It aims to inform policy to future-proof new housing provision and contribute to the government's commitment to reducing carbon emissions. That project was completed last year and has attained Passive House Classic certification. Another project Sharon is involved with is about to commence on site in March 2025. It's a deep retrofit pilot for a low-rise block of flats in Strabane, which will incorporate both ground and air-sourced heating installations. In addition to that, Sharon is an energy assessor and manages a team that updates the NIHE specifications and standard details, assists with larger scale schemes to provide energy improvements to the existing NIHE stock, and advises the regional delivery teams with business as usual works. So we have about an hour for our panel discussion this morning. So to start off the discussions and warm you all up, I have some questions from the registration forms that were submitted. And I'm going to direct those to the panel members while you think of your own questions. And there'll be lots of time then when those initial questions are finished for questions from the floor. So to start off, I have a question for Brenda from Gavin Maguire of FMB. Brenda, what do you think is preventing a retrofit programme in Northern Ireland at the moment? I think it's on.
Can you hear me?
Yes, that sounds good.
I think the barrier that most people jump to immediately is government grant programmes, and I know from speaking with colleagues in government departments, there's nothing they'd love more than to be able to set up and run these large-scale programmes. And we know that they are an important part of the picture because retrofit's costly. We know that when you have households that are committed to retrofit, you create a pipeline of projects. And we know that the construction industry, the retrofit industry, they need that in order to be able to provide the skills. So those grant programmes are an important part of it. It's very frustrating for us to be looking over at GB and to be looking at the Republic and think we haven't got that. And it's also it's easy for us to think that's a panacea as well. But for example, we're twinned with Galway City Council and a retrofit programme. And one of the things they're saying is even when households they've gone through the process and they're told, right, you've got grant funding now, there can be a delay of a year and a half up to 2 years to actually make those programmes materialise in the ground, because that takes us on to the other thing. The other big barrier is the skills gap. So even if the funding's in place and you've got the householders on board, you don't always have those people ready, because a lot of our people that are trained up in Northern Ireland are flying out to Dublin and GB, every week. I was speaking to the guy, one of the guys who was leading in retrofit in Wales. He came from a procurement background, and when he first looked at the retrofit programme in the UK, he was saying, "You lot are mad. You're poaching each other's staff. You're poaching materials. You've got materials that are produced in Scotland are getting ordered down to England, and then it's just we're all fighting and undercutting each other. So there's that material supply chain as well. And I think one of the other barriers for that is I'm sure Sharon will tell us more about their programmes, but I know we've spoken to Housing Exec in the past and we've heard about these amazing programmes that they have in place. We all think, God, I wish somebody would knock on my door and offer me a deep retrofit with all the whistles and bells. But you can hear that you can get a very strong pushback in some cases with social housing providers. Maybe up to 50% of householders can say that they don't actually want to engage. And I think it's very easy for us just to concentrate on the construction side, the building side of this. When you start to speak to the agencies like National Energy Action and Consumer Council, they're saying, unless you actually start to really consider the people in those homes, you're not going to get over that human element, that resistance. Because I don't know about you, but at the minute, I'm trying to get somebody to come in and put a new kitchen in for me. It's driving me up the walls, trying to pick somebody that you can trust, trying to get comparable quotes. And you just think that this is one of the other real barriers for householders. They don't know where to start, they don't know what to prioritise, they don't understand retrofit a lot of the time. And a lot of them are saying, can somebody just handhold us through this process? And when I lived in Scotland, I had exactly that experience when I went to get a heating system in. An organisation guided me through. It took a lot of the pain out of it. So I'd say the answer, it's a real, some of the big barriers are funding, it's the skills gap, and it's engaging with householders and making it easy for them to come on board. Thanks, Gavin, for that big one.
I think that really sets out what the challenges are and then maybe allows us to start to think about how we can address that. So the next one then is for Gavin. Gavin, what role do you think innovation hubs and research facilities like BEST play in accelerating retrofit at scale in both the UK and the Republic of Ireland?
I think we exist in that space that looks to deal with all those challenges that's just been raised, is to say that how do we exist to create a platform to allow for the emergence of one-stop shops for retrofit hubs for people to be able to engage and simplify what is a complex process. We see ourselves as trying to create these exemplar projects in a way that allows others to engage with it in more detail. Events like this give everybody confidence to see projects like the Google building and the projects that Craig demonstrated, that we make that available. So we see ourselves as a connection piece, as well as having to have a function where we upskill that supply chain that is so badly needed. We have to give the confidence to the sector that there is this pipeline of work coming, that we have the trades, the skills within our existing resources to deliver it, and we have confidence in what we're delivering. So we have to be able to say, if you do X, Y will be the outcome, and you can have confidence in that. And we also have to support the political and policy landscape. So quite a significant role across it, and I think what came up there was the idea of collaboration, this idea that it's one innovation centre in Scotland, or it's GB, UK, 4 nations, Europe, that actually we're all tackling with the same issues. We've got the same learning, and we can come together to kind of address this issue.
Thank you. The next one is for Craig. Craig, you showed really clearly in your presentation how useful whole life carbon assessment is in deciding how to retrofit effectively. But a question from Emmett McDonough-Brown from our ICS. What role do you think a whole life carbon assessment should play in deciding between adaptive reuse and new build construction?
Good question. So if it's deciding between a reuse or a new build, I think all of our presentations this morning have shown that a kind of whole life carbon assessment can show you where there are carbon savings. Obviously, there are lots of other factors that come into that. But I think that the whole life carbon assessment itself is kind of essential. Thinking about particularly the building in use upfront is very important, and we can get a handle on that, and we can see that happening. But what we are not so good at is kind of predicting the future use of the buildings. We can't see the future, so it's in our work it helps us interrogate a speculative future life of a building and design the building in a way that is going to make it low carbon and low resource use to retrofit that building. And I had an interesting conversation at the break about the D module in our visualization. The D is a kind of theoretical carbon savings in using the building, but obviously in the case of John's project at Google, the D in one of the previous building becomes savings in the A of the next building. So we do have to be careful about double accounting for where we're putting that in the whole life carbon, but I think being able to see the carbon life of a building and challenge the RICS assumptions, the assumptions that are in the RICS modules about how a building is actually going to be used, kind of essential for doing this.
Okay, thank you. So next we have a question for John, and it really follows on from your demonstration of how we can reuse structural elements within a building, structural steel elements. Do you sense there is a reluctance in the industry to reuse structural elements? And if you think there is, what can we do to encourage more reuse, and what should we be doing to encourage more reuse?
Good question on that. There's huge reluctance in the industry to reuse structural elements. Nobody wants to trust them. Everybody just wants to buy something new, just wants a drawing, a calculation associated with something new. Huge reluctance to go there. And it takes, people like ourselves pushing it to actually persuade them to do it, and to show that it is possible to happen. Like, we've looked at the low-hanging fruit. Steel is steel. You're looking at it, like as I was saying, you can see what it does. It gets a lot more difficult when you're talking about blocks, bricks, precast concrete, various things like that. But we have ambitions to go to those places with it. We have looked at it already on other buildings to see if we can do it, because our clients are asking us about it. And it's only when we come up with certain challenges that they start to push back. But at least we are starting that journey and going through it. One of the reasons I wanted to highlight that at the end of my presentation about the building regulations documents is that that kind of framework exists to allow us to use it to push back to the local authorities if they do give us pushback on it. Or down south we have this role that was created about 10 years ago, which is called a sign certifier, and so they're effectively an overseer of the design team and have to certify the building at the end. And what we hear colloquially from people that we work with is that certain sign certifiers are absolutely looking for brand new CE marked products, and if they don't get that, they're not happy. And that's why I'm highlighting that in the building regulations, that there is a route that shows that it is acceptable to use it and it doesn't require CE marking. But yes, there is a huge reluctance to use it. Partly because a lot of people think it's more expensive, partly because people think, you know, trying to salvage bricks and reuse bricks, and we didn't get any insurance pushback on the Google building. But there is that reluctance to do with it, to go there. Like, we were very lucky in terms of the Google projects, and we didn't highlight there, which is what is different about it is that Google were the owner-occupier. It's not like a lot of the traditional projects that some of us work on of speculative, that it's for example, an office building that then there's going to be a tenant coming in, and the landlord is constantly, a developer is trying to think, what will the tenant think if he comes in and he sees old raised access floor tiles, or he sees a shabby looking steel beam with a bit hanging out of it. But that's starting to change now. That's starting to change now, that it could possibly be a badge of honour. You know, the fact that, look at that piece of old steel that was reused in the building, there's history there. You know, so I think we should all exploit that and go that way, and that it shows the history of the building. Like, one of the patterns you see, and I see this from having worked with AHMM for the last 6 or 7 years, is that AHMM celebrate the old. They don't hide it, they show it there, they show the history, the knowledge of it there, and it's no longer about that white walls, you know, it's about showing the product, showing it on display. That's why we wanted to show the bits of steel hanging off, you know, so that people can wander around the building and go, look, that is reused, we're doing the right thing here ourselves.
Okay, thank you for that. So just to thank Sharon for joining us today, and I have a question for you from one of your colleagues at Northern Ireland Housing Executive, from Adrian Blythe. Should the current house builders and indeed NIHE construct a passive house or NFIT standards? And in your answer, if you could sort of set out some of the pros and cons of each. Yeah.
I'm obviously all bought in for, for passive house and for energy efficiency. We just finished a passive house, the first new build passive house scheme using MMC for social housing scheme there just in September. So there's obviously very many benefits for this in terms of, obviously energy efficiency, I would say, is one of the biggest benefits. Energy efficiency in terms of reduced carbon and reduced embodied carbon, obviously, and operational. Reduced fuel bills for our tenants. It's very important that we look at fuel poverty, especially as a social housing landlord. And we obviously can take that on. You were saying about Google being the owner-occupier. We're client and architects, you know, so we have the ability to do that. And we have the ability to also influence the market, hopefully, too, in terms of, we only did 6 houses. You know, we know that this is very limited in terms of the overall social housing demand. It's a 4-year waiting list in Belfast alone. So, but in terms of the housing associations, you know, to try and to be able to influence them, and with the likes of, say, even for the likes of our passive house, we used, you know, like low carbon heating and ventilating systems. So there's pretty much the guarantee of constant indoor temperatures, 21 degrees, good indoor environment, healthy in terms of the air quality, and also to do with LPS, the actual value of the properties, we've been told now that they can take that into consideration. So when we started with the pilot in North Belfast, that wasn't the case. It was a case in GB. We looked at a lot of our GB counterparts, and I think actually in ROI as well. And we were told that we couldn't get, there wouldn't be any additional value for the likes of a passive house scheme, which to me seems crazy because it's easier to heat, more marketable, but we're now being told that's not the case, and we're going to take it on board with our next one. So even in terms of, I'm obviously thinking in terms of a social housing landlord, I would like to keep these very much within our stock, but if they were within the right to buy, then there's added value there, and for the likes of developers and stuff too. Constraints, cost can still be, we found in our business case process a few years ago, this is before hyperinflation, that the costs were actually fairly similar to houses being constructed at that point. It was to SAP B using traditional methods. So we found it was, I think it was less than 5% anyway of a difference between this and them. It was MMC on-site version to passive house standard that we ended up going with in our pilot. So, you know, the costs, the skill set, resources, lack of materials, specialist systems. I'm making the constraints sound quite long here, aren't I? Well, they're all under the same thing in terms of, you know, sort of it is quite a narrow market, and it's quite a narrow market in Northern Ireland, as we find as well. So is that, I'm trying to think if I answered.
Comprehensive answer, and I think sort of from what you're saying, many of the constraints hopefully as the market develops will be diminished, and that cost thing that it's nearly equivalent I think should be quite attractive, and yeah, hopefully will be something that will encourage other developers maybe to take it up as well. Yeah, okay, so thank you very much. Everyone's been asked a question, haven't you, so far? I haven't left anybody out. Okay, we'll take this opportunity now to kind of ask for questions from the floor, so I just ask you to raise your hand if you want to ask a question, and we have a couple of roving microphones so I can get them to you. Any questions? Just so one there, first here on the third row, and then there'll be another one in the second row. And if you can start by saying your name and what organisation you're from, that would be very helpful.
Ben James, architect and PhD researcher at Ulster. Question I suppose for Craig and the scope of whole life carbon assessments. Do we need to start looking at the C modules for the existing building and retrofit, and what do you do with the materials you're taking away? Does that need to start informing decisions? Does that start to promote a circular economy as well if we're assessing the carbon that's being generated by the disposed of materials you take away in the existing building?
I'm not quite sure I understood the question, sorry. The C module and how we account for that?
So
the C module from the existing building before you carry out the retrofit, so do we need to start going backwards a bit and start looking at whole life carbon, including the C module for the building before you start working on the retrofit?
So from the waste material that's being taken out of the existing building?
Yeah, I sort of touched on in my previous question answer. That's that visualization I showed was looking at a building as a kind of isolated system from A to D and then to offsets, as if it's a kind of thing that sits in isolation, but actually the C and then the D becomes the A module of the next building if you're kind of dismantling that wasting. So you actually, a building's life is a series of nested life cycle things. So absolutely, yeah, we need to think about that. But what we try and use that visualization for is to, if we can stick a number on C and maybe D at design stage, which is, you know, decades in the future, maybe even longer if the building's got good, if we design a building with good bones, then what we're trying to provoke in our designs is thinking about that, thinking about facilitating somebody doing that with their A module in the front. So we need to be careful absolutely about not double counting this stuff in the kind of grander scheme of things, but in terms of our buildings, it's, yeah, using C and D to provoke decisions that make it easy for C and D, for the C and D of the building as it exists to become part of the A of the next project. Absolutely, yeah. So I don't think we've solved kind of the boundary between who's got accountable, who's that accountable for, and how we ensure we don't double count that. But absolutely, that's what we're trying to provoke to think about how the next building is used. Yes, thank you. Sorry for misunderstanding your question.
Yeah, and I'm sure that's the sort of thing that RICS is considering as they evolve the methodology, just where exactly accounting should be. And in the most recent iteration, there's been some changes already, and I'm sure that will continue as sort of the maturity in carbon accounting increases across the industry. Okay, so for this gentleman.
Hi, I'm Dr. Sadiq Ali. I'm a multidisciplinary person working for renewable energy, and I'm a freelance. We understand the problems that we had with the asbestos. Doctors today tell us that the plastic water bottles, they carry microplastics that can be dangerous for us. Now, in the sustainable industry, we are replacing a lot of material with plastics. Is any microplastics being detected in the environment that have been made? And is there anything being done about it?
That's an interesting question. I don't know if any of the panellists want to jump in with that one, or maybe, Gavin, do you want to talk about maybe some bio-based materials to give that perspective?
Yeah, I'm happy to be thrown under the microplastics bus. So to answer the question you asked, no, I don't know that we are measuring it. Obviously, using an embodied carbon metric at the start of a project in this, considering what the materials are that we are putting into our buildings and how that might have a wider impact for us, is incredibly important. So our preference being for naturally, locally sourced based materials in some way gives us comfort from that perspective, from a carbon perspective and also in terms of building health. But we're always faced with the question of what is potentially the next asbestos going to be and how do we use that. So a lot of the programs that we find it best is based on is making informed decisions in a clear way, recording that, and then using digital assets or twins of the building to record everything that's been put in, so that should we need to refer to it at a later date, that it is available and we can analyse it and see how easy it is to identify, as opposed to the system that we're in just now, which is largely we're not aware behind the surface of what has been built into our existing fabric buildings, which will also make it easier for us in terms of assessing what could be reused if the building is eventually retrofit or deconstructed to be reused off-site as well, if that in any way helps you at all.
Okay, thank you. Apologies for the throwing of the under the bus. So there's a question there from a gentleman in the middle of this section.
Hi there, Daniel Lockwood from Atkins Realis. Gavin, you mentioned that the funding that you're getting from the government is obviously on a kind of year-by-year basis, but then when we're looking at sustainability and net zero targets, it's obviously a much longer-term view in terms of 2030, 2045, which I think means that we make maybe short-term rush decisions to meet a funding constraint. And I was interested in your view, how can we as an industry influence government and funders to make more long-term investment decisions and help projects make the right decisions for the long term?
My hope is, although slightly pessimistic on it, is that we continue to gather that information and we feed it back as part of the process to say that in an honest way, an adult conversation about what were the compromises that we were forced into as a result of time constraints. So you've got, there's budgetary constraints, and then there's the funding application window and the process by which the money is allocated. I would like to see more done to in post-evaluation to see how well the money was spent and to evaluate to say, well, actually, is there a way we could do that? We talk a lot in the industry about lessons learned. It's about making that experience wider to say, actually, if we were given the same amount of time in design, pre-construction, pre-contract starting, would we actually have spent the same amount of money and delivered a higher quality product, or could we potentially have spent less money and achieved the same outcome? Unfortunately, the funding streams work yearly because that's how the government finance system works, and they don't know what they're getting. Each department doesn't know what it's getting next year. So there is no villain in this. That it's just the reality of the situation. But I think it's important that we feed that back and we're honest with the people in this room, that we say this will also be a factor in what is already a complex environment to operate within.
Thanks, Gavin. I have a sense, though, that question would also be relevant to some of the other panellists, and I don't know if Sharon or Brenda, you want to jump in and add some thoughts to it, or perhaps not.
It's the issue of lack of certainty. It just comes back to, I just have to agree with you that annual budgets mean it's really hard for anybody to make any significant investment. It means, if we want to have the skilled people in place. We need to be starting 5 years ahead of the actual work being in place. The material supply chain need that in place as well. So it's very hard for us to progress on that incremental basis. I can understand why the budgets come out on that level, or on that level of frequency, but yes, it makes it really hard for us to set up.
Mm-hmm. And is annual funding an issue at NIHE, or you're able to budget for longer periods, Sharon?
I suppose I know the original question was to do with, it was sort of energy efficiency measures, and I suppose one of the big things I should have said and I now can say is future-proofing. Mm-hmm. And that's why obviously, like, so we have 82,000 houses, and we've got quite a few big retrofit schemes. And one of them which finished is the ERDF European funded scheme. It was 30 million and we got 20 of that from Europe. Okay. So we're doing a sort of a mop up at the minute, just finishing that up. But that was for 1,400 houses out of, and this is like the non-traditional stock that we have. So yeah, the funding streams obviously are important. It's something it's very important to our corporate strategy, and we need to make the money available because it's like I say, it's very important to us to do that. But in terms of the likes of homeowners and things like that too, I think the funding streams in the North Zone is NICEP, isn't it? And
affordable warmth. Yeah,
affordable warmth, that's it. And I know there's a few other things in the pipeline coming up, but it's they're all still, until they're there, that's it. And we do miss the sort of expertise of the likes of SEAI and stuff in the South, so it's, but yeah, definitely the funding stream, we seem to fall in between the Green Deal and on what they have in the South. So,
if it makes you feel any better, when I was at the BEST conference, which is really worth going to, if you get a chance to go to BEST Fest, I believe it's free of charge. I think it's free.
Yes, it is. Yeah.
Yeah, it's a really, really good conference. But I had at least I got the choice to go on first, and I was asked to outline. So, what's the retrofit situation in Northern Ireland, and what's your funding scenario? And then had the guy from SEAI coming on to describe what their funding scenario was. I was so glad that he went on first. It's the juxtaposition of the two. It makes it quite hard. But I suppose one of the things about that, the only good thing about coming late to things like this is you can learn a lot from the other programmes. There's been a lot of coverage in the media recently about lessons learned about retrofit and repercussions if it wasn't installed and balanced properly. And I know that even SEAI say that if they were to turn back the clock, there are some things that they would do differently, like maybe how they put in quality checks, from the outset. So that's one of the good things about having neighbours who've, got a better funding system than us. At least it informs the development of ours when it does kick in.
That's very true, actually. The likes of us taking on the, certain standards as well, not just that, with, the likes of the PAS 2030, 35. The fact that we can base, we can base our retrofit works on the likes of standards like that too gives us more certainty as a social housing landlord, because we didn't have that in the past with our retrofit. It would have been more likely to be the likes of the cavity wall insulation and things like that in the single measures, and gives us a lot more certainty then for the future, the fact that we have third-party guarantees.
It's good to know there are some advantages to the funding being somewhat delayed. Okay, we have time for some more questions here on the front row, and then afterwards towards the back there, or second row. Thank you.
Hello, Matthew Dunn from Ryder Levitt Bucknell. One thing that we work a lot with is the skills gap and looking at setting up new hubs. And I think one of the key questions that we tend to try to address is what is the consistency in skills gaps in sort of individual skills that we can bring? And that can be, does that vary nationally? Will that vary with time? We were talking about the pipeline of, the needs in 5 years' time versus now. And I suppose then, what are the soft factors around that we can use to influence? Is there, a gap around maybe the location of hubs, their provisions, maintaining engagement, things to do with, the individuals that will be engaging with those, the students, consistency around or assuredness around cost and provision and flexibility, and also kind of maybe the facilities that we can provide for them, what guarantee is there around that, and how can we ensure engagement, that there's sort of adequate uptake as well as the provision of these centres of excellence.
Again, that's...
I feel like that was me again. Sorry. Yes to everything you said there. The pipeline is, as we see, is core. So what we need to do is we need to drive up demand. So we need the client base. So RSLs, local authorities, estate owners to be on the mission in terms of making this visible commitment to what they're going to do, and then we have to have a means by which that we can have a construction pipeline visible to the market. And then the geo-mapping of that will be, there will be patterns. Now it is likely that you're going to do a bit of everything everywhere, but there are going to be hotspots, there are going to be areas using particular archetypal analysis or particular investment strategies. In the example earlier on of the map that overlays sort of economic data against energy performance data. Now, whether or not you agree with those data sets, they do point to certain activities, and it is probably a good bet that those are the areas that are going to receive a bigger set of investment or more multiple measures, as opposed to different areas. But it's always going to be a challenge in terms of, we talk about a skills gap, but what we mean is we have skills, we have knowledge in the sector. This is about having people pivot or move their attention to a certain different area. That's incredibly hard to do. Even if you make it free at the point of access to them to do the training, they lose the wages or the jobs that they know. And what we find is, anecdotally, is things that get said all the time. If you take a very simple one, heat pumps, if you expect someone to retrain gas engineer to installing heat pumps, if they're a one-man band and they've got 2 years worth of work installing gas boilers, they have no need to do that. Even if you're saying it's free, I can train you in this. What they need to see is the 2, 3, 5, 10 years of work in that other sector. So it's incentivising it as well to see where is this actually likely to happen. So we all have to just be as honest with each other as we can be.
Does anybody else want to come in on that one?
I think one of the points, there's a consultation on low carbon heating. On the Council at the end of 2024, one of the questions they asked, because the consultation was largely around air source heat pumps, and they raised the issue of how could we have some kind of quality assurance to make sure that when people are putting in air source heat pumps that they are properly trained. Because I know that I'd spoken to some skills providers and they'd said, well, a good chunk of the people that we've got coming in at the minute to do these courses are people going, I put one in, I thought I knew what I was doing. There is quite a lot that people have had to learn for that. So it was good that they raised that point, and they were suggesting accreditation schemes to make sure that people can only install these measures if they are, properly accredited. I thought that was an important point. It's worth noting that I know that there is a green skills report that's in the pipeline in Northern Ireland. I know that one of our co-chairs in the Retrofit Hub, Barry Nielsen, who works for CITB, he was saying that they've pulled that together. It's imminent. It's just with government departments, and it's looking at exactly that. Where are the shortfall areas? But I know they're just one of the issues is that we know that the construction industry is struggling in general to get people in. It's an ageing workforce. We've got I think that the level of females in that workforce is something like 3% as well. So we're struggling to get people in on any level. So it is a real challenge. So, but one of the points is that when we're talking past 2035, when we were discussing that in the Retrofit Hub, saying, are you as our members, are you sending your staff out to get this accreditation? They're saying, well, we can't afford to send somebody off site for all that amount of time, but we can let them go out on a modular basis that's relevant to a project. So if it's a modest or micro project, it may not need full past 2035 accreditation. So it's making sure that it's any quality controller training that's needed is kind of, it's fit for purpose, it's proportionate.
Can I come in and talk? I think the skills sharing, these kind of formal funded ways of educating and upskilling people are very important. But I think also there's an onus on us as practitioners or whatever we're in just to kind of help do that. As an example, I was a group of friends 10 years ago, 5 or 6 of us used to go to the pub once a month to kind of hit our heads against the table and talk about how difficult it was to kind of drive sustainability in our architectural practice, which is, we kind of self-styled that as an architectural sustainability self-help group, But that's kind of grown into a network of about 150 practices across London. We meet once a month in each other's offices, and we just share stuff we've been doing, kind of within the constraints of commercial competitiveness and intellectual property, etc. But it's just a kind of loose network of people who just share stuff that we find difficult or ideas that we think are interesting. So I think, kind of onus on you and others to just get together and share, talk about this stuff and kind of learn from each other, kind of build a knowledge base.
I probably would just say add in everything that everybody else is saying. Also, that's why we looked at modern methods of construction. So, because of the fact that is it 55 is the average age of a site operative or something like that, or 53, it's not great anyway in terms of the workforce coming up behind them. So that was one of the reasons why we looked at MMC, as it reduces down the number of operatives that would be required. For the likes of our new houses, we tried to cut down the amount of wet trades that we were using. So there was looking at things like that. I know that's more dealing with the problem that we have at hand, as opposed to encouraging it for the future. But it's where we've seen is, if people work the likes of the, say, panelised factories and things like that, they're better conditions for people to work in, and they take people on, and they're not sort of serving their time in the traditional sense of the word, but they're still becoming skilled as they're working. So I suppose it's looking at different methods as well in terms of the skills gaps. So.
That's great, thank you everyone. And sort of picking up on Craig's point, one of the reasons that Queen's Estates have been establishing these conferences and running these conferences is to provide another forum to have these kind of conversations and to meet people. So I do hope over coffee and over lunch and we don't have a coffee break this afternoon, do we? No. Over coffee and over lunch, you get an opportunity to meet people and that you keep in contact with them. Was I right? There was a question down at the back there.
Hi, I'm Emma Houston from Troop by Waters and Anders. I've got a question for Craig about the kickback you got from the insurers on the reused brick. Did they share what their particular issues were, and was it to do at all with the extent that you're proposing, and also what point in the timing of the project did you find out that there was an issue?
So in that project, we did not get a justification from them about why they wouldn't. It was insurance. We found out as we were cleaning the bricks. So I say the image I showed of us choosing a colour of a new brick. On another project just down the road outside King's Cross, we dismantled a warehouse building to build the new office building, and we were building some social housing alongside it. And the idea was we were going to reuse the bricks from that warehouse to build new social housing, and in that case we got the same kind of insurance kickback. Our client had paid somebody to clean the bricks up, so we had thousands of bricks ready to be used. They said insurance was the problem. Our client said, what guarantees do you need, what tests do you need us to carry out on these bricks? We'll pay for them, give us a list of data points you need, and the insurers refused to let us use them, and we don't know why. It was just a kind of no. And literally an email around our office saying, does anybody have use for 40,000 bricks? So they're now sitting in a reclamation or somewhere. So no, I can't give you any more insight other than the sort of computer said no.
Just to say, we had a similar issue. We were discussing this last night, quite late in the day on their project. Another issue around the insurances of the site works was being explored, and the liaison we had just dropped an email to me just saying, oh, by the way, just to note that as long as you're only using A1 or A2 fire rated products and there's no combustible materials in any part of the cladding system, you'll be fine. So anyone paying attention to what the design is, it's all combustible materials and none of it's A1 or A2. This was well into construction phase. It had never been highlighted before, and luckily the question back was, sorry, is this mandated for us, or is that just a boilerplate that you've added into this email trail? And kind of gave our justification. We did everything to say, like, here's what it says in the technical standard, this is the height of the building, this is its use class, and put the justification back, and just got the one-liner of saying, oh no, that's okay, then that all looks fine. So sometimes you can just get the wrong person on the wrong day, or they've got a little bit of information can sometimes be a dangerous thing. And appetite for risk in insurance companies is fairly low. So you need to know that you've got your ducks in a row for conversations with them.
But in the case of the second case of trying to reuse buildings, I mean, we weren't using them in a structural, so presumably they're worried about structural integrity of the bricks, right? That's their kind of primary risk. But we demonstrated we weren't using them in the structural capacity. It was arranged, it was on an angle every floor, so they weren't doing any load bearing. It was essentially a bit of cladding, but they were just, for whatever reason, no.
And just to add to that, that was the very reason we went with the CE marking on the steelwork, so that if that question was ever raised, that we could have answered it, even though, as I pointed out, we didn't need it. We wanted to try and use a certification system that was available, and that's where it becomes a bit more difficult when you're dealing with concrete blocks and various things like that. And we have had a situation, we did a house in Dublin a few years ago where the bricks did come from a demolished factory in London. And it's just the client wanted to use them, and no insurance issue for us. Still standing, that was 10 years ago.
Yeah. I think that's a very useful kind of reflection on the realities of trying to do some of this work. And sort of certainly my experience from working with recycled materials sort of earlier in my career, things that were not possible 20 years ago have become possible in recent years. And my hope would be that as these problems are identified, that they can be addressed, but we shall see. We have some time for a few more questions. There's two up here at the front.
Thank you. Martin Felturner and Townsend. Just to pick up on that point with, especially with cement replacement or aggregate replacement in structural concretes, that's still an area where we're getting significant kickback from funders and investors that are very, very reticent to do that. I mean, obviously with steelwork it's a lot easier, but what's your advice on how to overcome that problem with funders and investors or developers that saying they just don't want that, we don't want to take the risk?
We don't see it as a risk because it's in the code. That's how we would take the view. So in terms of cement replacement, we first used GGBS in 2007 in a building, no issue at all. Never had PFA in the north or the south, from what I'm aware of. It's just GGBS that was imported. We've been using it. It's in all the codes, Irish and British, no problem at all. What we have a problem with reuse of aggregates down south is it's actually the EPA is blocking us. It's blocking us from the point of view of that when concrete or a building is demolished, it's classified as a waste material under EU directives. And it's at that point that it's about that it needs to be reprocessed. Even if it's on site, it needs to be reprocessed, and that's where the blocker is. But it's in all the codes. It's in the codes, the reuse of aggregates. It's in the British standard, it's in the Irish standard. I've pointed this out to the EPA. I brought the EPA to the Treasury building to point out what we were doing and show the process and explained it to them. And they said they didn't have the in-house technical experience in the Republic to actually change the regs at that point. And that's why there is committees that are set up to try and change it. So at each stage, and this is what we were trying to do in the Treasury building, we weren't actually trying to come up with something new. We were just trying to push it to the limits of the codes. That's why what David was talking about, the loading, that's not that we were trying to come up with something innovative. We were just telling Google we want to work to the code. So therefore, I have something that I'm able to defend, like I'm able to defend this now, and say we're not pushing beyond. When it gets to the stage where we're all working to the codes and we're all working consistently to the codes, and we find that we need to do something more, which I think we all know we need to do, that's when we start to have that discussion. I remember being at a conference in London where the question was asked, do you think we should reduce the imposed load of buildings more? And the guy's response was, no, because none of you are even working to the loading that we're allowed to use at the moment. We have to just push it to the limit, which is what we try to do. Use the legislation we have, use everything we have, and just push it. And what we find is the more you start looking into it and the more you start actually realising, like those clauses in the building regulations, it's available, it's there. But it is the insurance companies that cause the pushback. And there's a whole other conference to be had on mass timber, and that's when you're dealing with mass timber buildings, you have to bring the insurers along with you, and you have to modify your design in such a way to make them happy to insure you. And if you do that, you can bring them with you. So it's about talking to them and have your ducks in a row, basically.
I thought I saw you lifting your microphone. I would certainly add to that, because the example I was talking about 20 years ago was to reuse recycled aggregates within concrete, and it was at that time, although it was possible to do it theoretically, the client was very nervous about doing it because of durability, and only a couple of years later the specifications for reuse of concrete aggregates, recycled concrete aggregates in concrete came into place, and it's now used a lot more frequently here in Northern Ireland. Okay. There was a second question then at the front.
Hi, my name is Jair Perez. I'm a student at Queen's, and basically starting with the quote from Brenda that 3/4 of the buildings are not going to be usable by 2030, and also that retrofitting is not always the solution in the construction sector. Does any of your companies have already any type of approach for the buildings that are already in operation? Since most of them are already on the end of their lifespan, what are we going to do with the materials that cannot be recycled, such as probably the air conditioning systems that do contain fiberglass on them, or any other type of materials?
Clarify, sorry. So your question is, how do we reuse those buildings, or if they are not reusable, how do we use the materials within them?
Is there an approach on the, on all the materials that cannot be recycled? What are we going to do with them if they cannot be integrated into the circular economy with all the solutions that you have presented?
Who would like to try that one?
I would say I think it's safe to say we don't have all the answers just now. I think that's what we need to continue to look at, is to try and limit as much as possible those materials that are existing that we can't do something with. And we have to also notice and realise that we do have these life cycle plans for buildings, but our buildings are past their serviceable life on paper, that exist now that will still exist in 50 years' time as well, because we have a shortage, particularly of housing as well. We don't have the luxury of space, and we can't continue to keep building, and we can't demolish to create new sites because we have to have certain carbon accounting. So I think it's about ensuring that we have these things at the outset of every project, and it's considered all the way through, and you've got a framework in which you can make decisions. And yes, you will eventually come up with compromises, which are certain things you will not be able to recycle that will go to landfill. But what you then have to do is offset that by ensuring that nothing new that goes into the building then becomes someone else's problem later down the line when it has to be replaced.
If I could add to that, what we've noticed when we started looking at reuse of materials beyond the project I spoke about there and other projects we're looking at, is that the more valuable the material, the more likely you are to get it through in terms of reuse. So the example is steel, absolutely. The cost of fabricated steelwork could be €4,000 a tonne in Dublin. It could be more, it could be less. So when you're talking about that kind of figure, everyone wants to reuse steel because it's going to save money. Whereas it's the opposite, unfortunately, with, say, recycled concrete aggregates, because it's nearly cheaper to quarry the stone out of the ground. So you don't get those economies of scale associated with it. And if you think about it in terms of all the materials in the building, it's like your iPhone. They want it back from you because it's full of these really valuable materials. So it's like that. The difficulty is with your fan coil units, which are full of metal and full of lots of gadgets and that. Once it's taken out of the box and once the warranty is gone, nobody wants to know about it. Everyone wants a new one. But yet the materials themselves in itself are very valuable, which is fantastic. When you start looking into raised access floor tiles and ask about the recycling of it, and the suppliers will tell you we recycle it. And then when you dig a bit deeper, you realise what they do is they shred them, they extract the metal, and they burn the timber. That's no good, but yet they're taking the valuable products out of it. what we all need to be doing is, and manufacturers need to be designing it as well now, is the manufacturers need to hear about module C and D, and the manufacturers need to be providing material, they need to be designing their products like the way engineers and architects should be to designing the products for deconstruction as well, so that you can take apart these and you can reuse them. It's either that or you do, as Craig says, you design with things integrated into it and they last much, much longer, so you don't have to recycle them.
I was also going to say two things on that. We talked about the stage C and kind of thinking ahead to speculating about how a building might be reused and sort of facilitating that through the design. But in the case of Boland's Bakery, those steels were never thought about as, it doesn't look like they were thought about as being a reusable thing in the original design. So the value proposition suddenly makes that a viable thing to do because we're interested in carbon, we're interested in value, and you have a clever engineer comes along and thinks we can do that. So they find things to reuse in a building that weren't ever intended to be reused or weren't thought about as being reused. So I think some of these things you're talking about will become reusable as the value changes. And I suppose the other aspect of that is that in some of the demolition projects we're working with demolition contractors who are beginning to sort of change their business from demolition to dismantling. And along with that comes a completely different business model where before they would price a job based on some of the stuff they can salvage and shift on somewhere else, whereas now the client takes ownership of that stuff. They go in there, they've got a health and safety issue because now they've got an electrician up a step ladder carefully taking down a light fitting, whereas before they would have not been quite so careful about it. So as the value of these kind of recyclable things becomes greater, I think the industry will adapt to being able to take them out and find a use for them in the future.
We've talked about this a lot in the Retrofit Hub from the economic point of view, because some of our members work in real estate, I suppose, and they're working with a lot of their clients who own buildings, but they aren't fully paid off yet. And so these clients who own major buildings, all kinds of buildings in any area, they're saying that they're struggling to lease or sell buildings, even if they've got a relatively high energy performance. So what real estate are telling us that even if a building has, BREEAM Excellent or some other equivalent high rating, then they can generally let it. A B, they might have some trouble shifting, but if it comes to anything below that, they're saying they find it really hard to lease these buildings out, and increasingly so. And so what they're saying is they're speaking to their clients and saying, you need to go and speak to your bank about your portfolio to explore what your options are, because if you don't invest in that now, you are going to have a stranded asset, and we know that there are stranded assets already in Belfast for that reason. So it's interesting, that's how real estate are looking at it, and the banking sector is looking at it in the same way. What can we do to bring these buildings back into operation? We've been speaking to a really interesting guy called Martin Haran out at Ulster University. He's one of our active members, and he'd been talking to us about, I think it was a European project called Café Crème, and they were looking at this is a common issue that faces all of the large cities in Western Europe, that a lot of their buildings are effectively no longer fit for purpose. But what he was saying that you've got long-term institutional investors who are coming and looking at this kind of stock and saying, okay, how can we reorientate that? How can we bring it back into economic use? And their starting point is to look at these cities and look at what is the carbon footprint of that office stock and what are their options, how can they invest, which buildings could go over from office space to domestic. Now, I'm a climate professional, not a building professional, but it made a lot of sense to me when they said that you can't just automatically take an office building and suddenly repurpose it for domestic. I suppose the phrase you were using today is having good bones. But so that gave us a lot of food for thought. It was something that we're chewing over a lot from the Retrofit Hub.
Okay, was there another question over there, or have we done both of those questions? We've done both of those, yeah? I'm very conscious that the conversation is good, but we are approaching lunchtime, and we have a lot of people to feed for this lunchtime, so I'm going to draw the panel discussion to a close now, and allow you all to go down and get your lunch. Thank you very much to all of our panellists for your thoughts and your comments, and to the audience for asking some really, really thoughtful questions.